Hi, I'm Sagar, your instructor for this course with experience in designing and developing several software projects. If you are an absolute beginner or someone coming from a different technology background and looking to get started with programming, then this course is absolutely apt for you. As a beginner, you may tend to get confused whether to learn C language or some other language and so on. Believe me, C language is the best language to get started with. Because C language helps you work on your basic programming skills, it acts as your first milestone. Thorough understanding of programming basics are a must for any software developer to do well in programming. The primary focus of this course is to help you get started with programming and fine-tune your programming skills by giving deep insights about individual topics through several simple and easy to understand examples. Well, with all my experience, I'm telling you, no second thought. Let's get started with this course. All the best.
Studio Code is one other code editor which can be used for building C language applications. Go to code.visualstudio.com and open the corresponding application based on your operating system. I downloaded it and I installed it. Once done, open the editor. Now you just need to add one more extension. So here you can find this extensions icon. Go to extensions and then choose C and C++ extension. And here, because I have already installed it, it is showing me as installed. So here the uninstall is in order to remove it. Now for you, because you just installed it, you should be able to see the install button here. Just click on it and install that extension. Once done, go to the folder. You can open the folder where you want to put your example files. Let's open the folder. I'm going to create some examples folder in the desktop. And here I'll place the example files. So just open it. And here you can find the icon to create a new file. So create a new file. I'll say first.c. Now you can start typing your code here. Let's say include stdio.h, standard input output header file. These things will be explained in the coming lectures. Don't worry about it. And your main method signature, int main, and return 0. And printf hello world. So this is your example program. So in order to compile and run this program, you first need to open the terminal, right click and open in integrated terminal. You can see you have a file named first.c. Now again, gcc first.c to compile the file. And it compiled. So if you see the output, you can see the output file is a.out. Now, if you are looking to create your own output file instead of the default name a.out, you can also do that. gcc first.c -o for generating the output, and I want that to be in first. Now you can see you have 3 files now. This was the old one. Now, because as a result of this command, you can see that it generated a file called first. Now that is the executable file which you need to run. So /first will run the file. You can see that you got the hello world. That's it. Congratulations. You are done with your first program, and let's start exploring more. Now let's dive in and see what is happening with the hello world program. Now, if you are an absolute beginner, maybe these parentheses and braces, all those things might be slightly confusing for you. Don't worry. Once you move along in the course, you will understand these things. So main is the first function to get invoked. So if you can think of it as a main gate in your house, okay? So that is where the things get into, right? Similarly, main is the first function where the execution begins from. The functions in mathematics are normally written with parentheses, right? f of x equal to x square, something like that. So you are using parentheses here. Similarly, functions has parentheses here. Okay, so and you need to remember that each parenthesis will have a closing one. So if it is a opening brace, there will be a closing brace as well. So if it is an opening angular bracket, so there will be a closing angular bracket. So it's, just to make things simple. Okay, and main has a return value which is an integer, which says that this is function is going to return an integer at the end of the program. So what do you mean by this? The return value of main normally indicates that how the program exited. So whether it is a successful exit or whether it is a failure. Now 0 normally indicates the successful exit, and any non-zero value normally it indicates a failure or some sort of failure. Now when you launch a printer process and you are asking it to print something, it might fail with several reasons. So printer pages are not available, or maybe cartridge is empty, something of that sort. Similarly, end of exit code of a program normally indicates how it terminated, how it ended. 0 stands for success and any non-zero value stands for failure. So this integer here is saying that this function is going to return an integer value. So and these two are related. And then you look at the braces here, right? So this is something that is called as a compound statement or a block. So this combines multiple statements into single one. So in English, if you look at it, a statement ends with a full stop. Similarly here, the statement ends with a semicolon. And there may be multiple statements. If you look at all individual things, you can look at it as three different things here. Now, how these three things can be combined into one? So for that, in C language, we use these curly braces. So these combine all the multiple statements into one single statement. Normally, you have 1, 2, and 3. Now it is one single statement. So that is the main purpose of this block. And you are using something called as printf. So printf prints some message into the console. So this printf is coming from stdio.h, and that's the reason you included this file called stdio.h, which is a standard input-output header file where you will find the declaration for printf. In order to use the printf, you need to include this file. So this is at a high level. So what is the program we have written? Don't worry about the syntax. You will understand each and everything once you start moving along, right? So let's move along and understand how the compilation works. So you have a file called hello.c, and this is your program, and you need to give this program to the compiler. So why compiler? Normally, whatever the program that you have written, that is what we call as high-level language. Okay, it's something slightly easy for us to understand. So machines understand machine language. Okay, machine language is a combination of zeros and ones. It has a processor will have its own instruction set, and there is a specific way to write the instruction and all those things. And for us to write the programs using machine language is near impossible. So we write it in high level languages like C, Java, Python, whatever it is. And these programs need to be translated because this is somewhat closer to our language. Okay, so this need to be translated to machine language, and this process is done by compiler. So compiler translates this program to machine language code or translate it into executable form. Executable means it's something which is executable directly by the processor. So, but there is an operating system dependency in between. I don't want to dig too deep into that. Now, the C language program is submitted to the compiler, which translates that program to machine language or executable form, which is then submitted to the program operating system for execution. Now to submit it to the compiler for translation, we can use GCC, which is a tool normally available in Mac and Linux machines directly. Maybe in Windows machine you might have to install it. So GCC and followed by the file name, which compiles the program, and it generates a file called a.out, which is what we call as executable. We can also specify our own file name if we want. And then when we say /a.out in the command prompt, right? This particular process is submitted for execution, or we are submitting it to the operating system to execute this program. then operating system takes care of taking that program to memory and then submitting it for execution, and all those things it takes care of. So this is at a high level what you have written. Syntax wise, don't worry about these things for now. Slowly you will understand once you get into the scheme of things. See you in the next lecture.
Let us now get started with a simple programming example. We need to add two numbers and display the result. And for that, I am just creating a new C language file here. Let us say new file, and I would name it some add.c. Now, in order to use printf, I would use #include stdio.h. That's fine. And every program, as you already know, begins with main, int main. Don't worry, even if you didn't understand these concepts now, in future, slowly you will get to know what is the block and how it behaves. And also just say return 0 for now. Now these things are fine. Now in order to add two numbers, I need three variables. What are variables? You will come to know. Now first thing, I would declare three variables int a, b and c. Now when I say int a, b, c, you get a memory block with name a, and you get another memory block in memory with name b, and you get another block with name c. Now let's fill a, b, c with some values. Let's say a equal to 10 and b equal to 20, c equal to a plus b. Now what happens after these three statements? When I say a equal to 10, the value 10 is stored in a. Now when I say b equal to 20, value 20 is stored in b. Now I say c equal to a plus b, here the added result of a plus b is stored in c. So that is 30. Now we just need to print the value of c. Let's say printf, and the type of value that you want to print, %d, that is an integer, and followed by c. Here when we say %d, we are trying to place an integer value in the output string. Instead of saying %d, I can say value of c is. Now when we say value of c is, it is a plain string. And here when we say %d, now here this will be replaced with the value supplied from outside. So this will be replaced with the actual value of c. Now in order to run this program, go to the command prompt, and we need to change to the folder where this particular file exists, and I am inside that folder. Now gcc and followed by the file name, so that is add.c. It compiled successfully. You can see the file called as a.out, which is an output file. Now let's run the file /a.out. Now you can see that the value of c is 30, so which is an added result. Now if you look at it, the entire text is printed in the same line and also the command prompt that followed. So I would say /n, which is called as a new line character. Now once this text is printed, cursor is moved to the new line. Now let us see what is the outcome of this. Again, you need to compile the program. Add.c. Now /a.out. Now you can see that the value of c is 30, and then a cursor is taken to the next line. Now instead of giving the fixed values to a and b, I want to read these values through the input. And for that we can use the function called scanf. Let's say scanf %d. So the type of value that we are looking to read is an integer, and where to place it? We need to place it in the address of a. And scanf %d, and we need to place this in the address of b. So what we are saying here is, we are asking the scanf function to read an integer value and place it in the address of A. What is it? We will see what it is. Now before that, let's run this program and see what is the outcome of it. Let's say gcc add.c. Let compile. Now let's run the program. /a.out. Now your program is waiting for a value. You don't know that this is waiting for a value, but still, because of the first instruction, that is scanf, it is waiting for a value. Let's give a value. Now this value is placed in A, and then again it is waiting for a value. Now if you supply the value, this is placed in B, and now the added result, that is A plus B, 20 and 30, is added and its value is placed in C, and you will see the value of C is 50. But it would be nice if we can put a prompt before it. So for that, I would like to do this printf enter the value of A, and again printf enter the value of B. Let's see what is the outcome. Now you see that enter the value of A. Now you will come to know that you need to enter some value. So this is what we call the prompt. We are just taking the help of the printf statement to print the prompt. Now it's waiting for value. Let's give some value, say 40. Now again, this instruction is completed and its value is placed in A. And you can see that enter the value of B is printed. Now let's give some value, let's say 60. Now the entered value is now stored in B, and then the value A plus B is stored inside C. Now you can see that the value of C is and followed by %d. This is the placeholder. Now we are saying that the value of C should be kept here. Now in order to help you understand this, I would like to explain you with a simple example. Assume there is a house and its address is somewhere ABC. Now you are an individual and you are given a simple parcel, and you are asked to deliver this parcel to the address ABC. So what will you do? You will simply take this parcel and hand it over to the person residing in this house with the address ABC. And similarly, each variable in memory will be having some address. Let's say the address of A is 1000 and the address of B is, say, for example 1500, and the address of C is 2000. Now let's assume, so this is just say I'm not saying that this is the place where it will be, but there will be some address where A is actually residing in memory. Now when we say &A, you are going to get the address of A. So that means scanf function will know that the value entered should be placed inside the address of A, that is 1000. So when you enter 40, now it actually puts that in the address of A, that is 1000. So it goes to A. And then when I say the next time, when I enter 60, it is kept in the address of B. And that means the address of B, say for example 1500, then the value 60 is kept inside B. Now when we say C equal to A plus B, this is where we need to understand the right hand side will be evaluated first, and then its value is assigned to the left hand side variable. So here the right hand side is A plus B. A plus B is 40 plus 60, that is 100, and then its value is kept inside C. So you will see the 100. Don't worry, even if you didn't understand certain parts of this code, you will understand once you move along with other lectures. Now that you know how to add two numbers, now let us try to solve this problem. Now here I am listing the few arithmetic operators for you. Plus for addition, minus for subtraction, asterisk for multiplication, slash for division, modulus for remainder. And these are the operators. You need to calculate the values of A plus B, A minus B, A multiplied by B, that is A asterisk B, and a divided by b and a modulus b, which is the remainder. Now let us not worry about this integer int a comma b comma c and other syntax that I will be explaining you anyway in the coming lectures. Now let's see how to solve this problem. Now I am going to create a new file. I'll name it as arithmetic.c, arithmetic.c. Now I'll be copying the same content. That's fine. Now we actually need to read the values of a and b, and also we need to calculate the values of these expressions. And for this we need two variables a, b, and followed by c for holding the addition result, d for subtraction, e for multiplication, f for division, and g. Now you can name the variables as you like. Here I just kept it for simplicity. Now the value, we are first asking for the value of a and we are reading the value of a, and then we are asking for value of b, we are reading the value of b, and now we are doing the computations. So c is equal to a plus b, that's fine, it is already there. D equal to a minus b, e equal to a asterisk b, f equal to a divided by r slash b, which is for division, g equal to a mod b, which is the remainder. Now we calculated the values. Now just need to print those values. Value of c is, it's already there. Value of d is d. Value of e is, put the value of e here. Value of f is, and value of g. Now let's run this program and check the outcome. First you need to compile the program. So for that gcc arithmetic.c. So compilation is done, it is successful. Now you can see that the output file is created. Now let's run the file ./a.out. Now enter the value of a, I will say 10. Enter the value of b, that I will say 2. You can see the value of c is 12, 10 plus 2 is 12. And then d, that is 10 minus 2, 8, that's fine. 10 times 2, that is 20. And 10 divided by 2, which is 5. And remainder when 10 is divided by 2, which is 0. Now let's run the program again and see what is the outcome. I'm going to give the value of a as say 12, and now I'm going to give the value of b as 5. You can see a plus b, 12 plus 5 is 17, that's fine. 12 minus 5 is 7, 12 times 5 is 60, that's fine. Now here you can see that the value of f is 2. 10 divided by 2 is 2.4. But why you got only 2? And this is because f is an integer and it only holds the decimal part of it. It cannot hold the fraction part. For this we need to take some other data type, and I will explain you what to take in the coming lectures. And then the value of g is 2. So because 12 when divided by 5 you get the remainder 2. Before jumping further, I want you to read the value of 3 numbers, and you can do that by declaring 3 variables and reading 3 variables here, and print the average of those 3 numbers. So we will see how to solve it in the coming lecture. Now let us see how to solve this problem. I'm going to create a new file, naming it as avg.c. As usual, let's include stdio.h for printf and scanf. Now, in order to read three numbers, I will declare three variables, int a, b and c. Now, let us also read the values of ABC and say enter a and then scanf %d comma ampersand a. Similarly, say enter b, scanf %d ampersand b. Enter c, %d ampersand c. Now we got the three values. Now we need to calculate the average of these three. Now in order to hold the average, I am going to declare one other variable, name it as avg, and then avg equal to a plus b plus c by 3. Now let us print the value of avg. Average is %d and followed by avg and return 0. Now let's run and check what is the outcome of this program. And also I will put /n in order to take the cursor to the next line. Now compile the program gcc and followed by avg.c. Now run it, a.out. Now enter the value of a, I am entering 3, b is 3, c is 3. Now the average is 7, is it right? No. This is because our expression is wrong. We need to correct this expression. Now directly I am going to correct this expression. I will say I will use parenthesis here. Now let's check what is the outcome. Compile the program and execute it. Enter a, 3, 3 and 3, and you can see that now that you got the right average. Now what happened here? Let us evaluate. Now before you can understand the evaluation of this expression, you need to also know basic information about priority of operators. Now given that you know these operators, first priority would be for parenthesis, second priority would be for slash, asterisk and modulus, third priority would be for plus and minus, and then later the assignment operators. Now if you look at this expression, the operators present in this expression are assignment, plus that came twice, and then followed by slash. Now what is the higher priority operator here? So that is obviously c by 3. Now this is evaluated first and the result, let's say r1. Now the rest of the expression becomes avg equal to a plus b plus r1. Now here plus occurred twice, and because both are having same priority, whichever occurs first from the left will be evaluated first. So that means a plus b is evaluated first. So let's say that the result is r2. Then finally r2 plus r1 is evaluated. Let's say the result is r3. Now the result is then assigned to avg, and this is how expression is evaluated. Now in order to correct this expression, we used parenthesis. Now when we put parenthesis, parenthesis is having higher priority. So let's say priority 1. Now in this case, parenthesis is evaluated first. Now here within parenthesis, we again see plus twice. So whichever occurs first from the left, so will be evaluated first. Now this a plus b is evaluated first, let's say r1, and then r1 plus c is evaluated. Let's say that the result is r2. Then r2 by 3 is evaluated, and then it is assigned to avg. So you will come to know in detail about this expression evaluation structure once you go through the rest of the topics. Before jumping into how the expressions are evaluated, let us first understand some other basic definitions here. Here when we say int a, we are declaring an integer variable. So that means you are getting a memory block which is capable of holding an integer. And A is the identifier for this, just like your name. So your name identifies you. Similarly, this memory block is identified with the name A. Hence, we call it an identifier. And this is what we call an integer variable. So why it is a variable? And this is because the content of this memory block could be modified, could be changed. So here when we say A equal to 10, we are initializing the memory block with the value 10. And later when we say A equal to 20, this is also an acceptable statement. So this may changes the value of A to 20. Because we can modify, we call it a variable, and the type of value that we are going to store is an integer, so it is called an integer variable. Similarly, on the other side, when we declare a variable as constant, so the keyword const makes the memory block constant. That means, as the name indicates, you cannot modify the content of this memory block. So the memory block that we get cannot be modified. So here we are initializing B with 10. So initially the value 10 is set to B, and then later when we try to modify, this is not allowed. So compiler will throw an error. So during the compilation itself, you will see that you cannot modify B. So once the value is initialized, you cannot modify a constant. Hence this memory block could be called as constant integer. So similarly, C language supports these few other data types here. So that is character, integer, short int, long int, float, double, and long double. So out of these, we can classify them into two types. One is integral types and the other is floating types. These floating types are capable of holding the fraction part as well. These types vary in size. You take the right data type based on the requirement. Now, double is the preferred one out of the floating types, and int or long is a preferred one when it comes to integer types. Why character is an integral type, we will discuss about it in the future lectures. If you take a look at this example, when we are trying to store the fraction part, then integer is a wrong choice here because it truncates the fraction part and only takes the integer part of it. So that is A will be 5 itself. But whereas when you want to store some fraction part as well, so then you can pick from float or you can pick from double. But float is less accurate than double. So if you look at it, it will be a slight adjustment in the value. So somewhere around 5.3999 something. When it comes to double, it is more accurate. So for floating types, your preference should always be double. Now let's understand how the type conversion works. Before that, I want to remind you about a simple type conversion that you did in your childhood. Let's say you are asked to add the two values. Now, how did you add this? In your childhood, you might have done like this. 2, you might have written it as 02, and then you might have added this result. And similarly, one other scenario, let me tell you. 12.5 when added with 2. So how did you do this? You converted this to 0, 2.0, 12.5, and then you got 14.5. So very similar to this, when a compiler is asked to operate between two different operands, let's say one is a long and other is an integer. Now some operator. Now integer, it converts it to long and it then operates with that long, and finally you will see a long. Similarly, when one of the operand is a float and the other operand is an integer, now it converts integer to float, and then end result you are going to see in the float format. Now let's get back to these expressions. Now in this expression, a is an integer, b is an integer. Now a by b results in an integer, no conversion required. So 7 divided by 2 becomes 3, not 3.5, because the result is an integer and it is then assigned to C. Now let's get back to the second expression. Now in this case, C is a float, A is an integer, B is an integer. Now end result will be an integer. No conversion required among these two, and that is 3. Now in order to assign an integer to a float, integer is then converted to a float. That becomes 3.0 and then this is assigned. Now here, though C is a float, but still you will see 3.0, not 3.5. Now how to correct this? Now let's come back to this expression. Here A is an integer, B is a float. Now integer need to be operated with a float. So integer will be converted to a float internally, and then the end result is going to be a float. So here 7 becomes 7.0 and 2 becomes 2.0 anyway. So now the end result is 3.5 because it's a float, and then it is assigned to C because C is also a float, no conversion needed. Now in this case, A is an integer, B is an integer. Now here this is called as explicit type conversion. Now what is the purpose of this is, this is actually informing the compiler to consider A as a float. So compiler internally translates this integer into a float and then evaluates the expression. Now 7 becomes 7.0. Now float need to be operated with integer. So integer will be converted to a float, that is 2.0, and float divided by float, you will get the result in float format. So that is 3.5. 3.5 is then assigned to C. Here no conversion needed. So for evaluating the expressions properly, you need to perform some explicit type conversions in order to make sure that the expression produces the right result. Now let's come back to our previous example and see what is going wrong. Now here we are not going to change the data types. Obtained marks, total marks are going to be integers and percentage is a float. Now float, percentage is a float, obtained marks is an integer, total marks is an integer. What about 100? 100 is called a literal value, and even this is given the data type, and because it is 100 it is treated as an integer. Now let's evaluate. The first element to be evaluated is obtained marks divided by total marks, because both slash and asterisk both has same priority. Whichever occurs first from the left will be evaluated first. So this is evaluated first and there is no conversion required. So the result is going to be an integer. And what is the result? 758 divided by 1000, which is 0.758. So 0.758, we are only considering the integer part because it's an integer and hence it is 0, and 0 into 100, which is again an integer, that is 0. So our expression is wrong. Now let's take a look at what happened in the second scenario. Here obtained marks is integer, 100 is an integer, total is an integer. Now first here asterisk will be evaluated because it came first from the left. So obtained marks into 100, which is nothing but 75800, and which is an integer, and integer divided by integer is again an integer. So though it is 75.8, only 75 is taken, and then it is converted to a float before it is assigned to percentage. So you get 75.0. Now in the third case, obtained into 100.0 by total. So here obtained is an integer and 100.0 is actually a double, which is an extension for float. Now total is an integer. Now first obtained into 100.0 is evaluated. Now in this case the result is going to be a double because integer is converted to double. Now this becomes 75800.0. Now double should be evaluated with integer. So here integer will be converted to a double. So and end result will be a double value. which is 75.8. Now this is then assigned to a float, and after losing a bit of precision, you might actually end up seeing the same, almost the same value. Now you can also solve this expression using the explicit type conversion. Now here you are saying that obtain should be considered as a float, and float divided by integer, so which results in a float. So that is obtained marks divided by total marks, 758 divided by 1000, which is nothing but 0.758. Now 100 is an integer, so float multiplied by 100, so which is again results in a float, that is nothing but 75.8, which is then assigned to percentage. Now if you are expecting a result with high accuracy, you need to make sure that the expression is converted to a double at some point, and also evaluate the expression based on the priority of operators to check that everything is going proper. Now ideal scenario would be, instead of float, we might have declared this as double for better accuracy.
So we are using printf, we are using %d, and we are doing a lot of things there, right? So what is actually happening? So int a equal to 10, b equal to 20, these are two different variables with the value 10 and 20 respectively. That's fine. Now when we say printf, the value of a is %d, this content, you can think that the content is sent to the monitor, where %d is actually replaced by the value supplied. So here the value is supplied is a, so that is nothing but the variable a. Now if we give 100 here, so the value supplied is 100, it's a direct value. So if we give a the variable name, so variable value will be substituted in place of %d. So that is, here you will see the value of a is 10. Now just understand the difference between the a here and a here. The value a here is string, so within the quotes. Now this %d acts as the placeholder. So it actually takes the value that is supplied as an argument, the following argument. And then when we say /n, after printing this statement, when we say /n takes the cursor to the next line like this. And then if we say a is %d, so b is %d, something like this. So this will be printed here. Now the first %d is replaced with the first value, and the second %d is replaced with the second value. So %d here is the value of a is 10, that is the first value, and the value of b is 20, so that is placed in place of second value. So that is something that you need to remember. So wherever there is %d, it is replaced with the value which is supplied, and you should use the corresponding format specifier. This %d is called as a format specifier. You should use the corresponding format specifier in order to print the right kind of value. Now here first %d is replaced with the first value supplied, and second %d is replaced with the second value supplied. Now let us see what are the different format specifiers available. So normally integer is a signed integer, so it holds numbers with negative and positive values. And in 32-bit machines, normally it is 32 bits, whereas in 16-bit machines, you can see that there's 16 bits. So based on the size, depends on machine. So, and for printing an integer, you should use the code %d. Okay, so d for decimal point value. So that's why it is %d. And you will also see another data type which is unsigned. So unsigned means it only holds the positive value. So in case of an integer, if you say if it is 32 bits, then normally the value range 1 bit is for sign bit and rest of the 31 bits are allocated for data. In this case, you will see plus or minus 2 power 31 normally. That is the actual range. But in case of unsigned, all 32 bits are used for data. So the value range will be 0 to 2 power 32 minus 1. So this is the normal range. So let's not dig too deep into that. It's fine. Now, in case of unsigned integer, only positive, it can hold only positive values. You should use the code percentage UD. So U for unsigned decimal. Okay. So you will see long variable, which is the double the size of integer. So this can be printed using percentage LD. Okay, long decimal or long integer. Now, in case of unsigned long, so this will be again all if long is 8 bytes, so unsigned long uses the complete 8 bytes. So the code is percentage LU, so long and U for unsigned. Float for floating point values. So for that, you can use the code percentage F for float, and double is double the size of the float, and it is more accurate as well. So use double wherever possible, and the code you need to use is percentage LF. It's like long float. So double the size of float. And character is a single character. If you are looking to print a character, use percentage C for character, and you will see strings in future. And in case of string, you need to use percentage S. So these are the different format specifiers that you can use while printing. Just remember, wherever you are trying to print the value, so you should supply them from external argument, and format specifier, the right kind of format specifier need to be used. And whenever you need a new line, use the /n character, which is slash followed by n, which is a new line character. And anything that is followed by slash, normally we call it as escape sequence, escape for slash, and the sequence character followed by escape tells you that it is not a simple n, it is something that is a special character. So that is /n. So /n will take the cursor to this point, so that the next line which is printed will come in the next line. So this is about format specifiers. Let's move forward and look at the other examples.
Now let us understand one of the most important operators of C language, and it is also interesting as well, and that is the increment operator. Now increment operator is responsible to increment the variable by 1. Now if you take a equal to 10, the value of a is 10. Now when we say a plus plus, the value of a is incremented by 1. So that means a becomes 11. Now this is pretty simple and straightforward, and similar is the case with a minus minus as well. Now when we use the minus minus operator, it decrements the value of the variable by 1. Now that is fine. Now what is the real difference? And the real difference is with the usage of the operator. Now that means there are two different ways in which you can use it. One is the pre-increment and the other is the post-increment. Now pre, as the name indicates, the operator is placed before the variable, whereas in case of post, the operator is placed after the variable. Now does this really make the difference? Yes, and we will see how. Now here we took a variable a equal to 10. So the value of a is 10, and we also have another variable b. Now the expression b equal to plus plus a, what does this really mean? Now this means increment a by 1. So anyway a is going to be 11, but what value is substituted here is the question. Now because this is plus plus a, you are asking the a to be incremented before the substitution. Now that means a is incremented before the evaluation of this expression, and the incremented value is substituted here. Now that means b also becomes 11. Now let us see the other side of it. Now when we say a equal to 10, we have a variable a with value 10, and then we have another variable b. Now b equal to a plus plus, this means increment a afterwards. Now what is the current value of a? That is 10, that is placed here, and then after the substitution a is incremented by 1, which makes a as 11, and the current value of b is going to be 10. So pre-increment increments the variable before the substitution, whereas post-increment substitutes the current value of the variable and then it increments. So that is the main difference. and I would recommend not to go too deep into this. It is fine. If your understanding up to this level is proper, that should be more than enough. I'll show you this with an example, and then we will see how the variable value varies. Similar is the case with the decrement operator as well. So when you say a minus minus, this is called post decrement, and minus minus a is called pre decrement. Now in case of post decrement, variable is decremented after substitution, whereas in case of pre decrement, variable is decremented before substitution. Now that is the difference that you need to understand. Now let us see this with an example. I'm going to create a new file. I'll name it .c, and as usual, now int a equal to 10, I'll say a plus plus, and I'll print the value of a. A is percentage %d and a. Now let's see what is the outcome of this program. Now a is 11, so there is no change here. Now what happens, I am going to declare another variable b, and I will say b equal to a plus plus. Now this means increment a later. Now what is the current value of a? That is 10. And 10 is substituted here, so that means b becomes 10, and later a is incremented by 1, so a becomes 11. Now a is, and b is percentage %d. I'll also give b. Now you can see that the value of a is 11 anyway, so a is 10, and when we say increment a by 1, a becomes 11. But see what is the value of b, and the value of b is 10 because the current value of a is substituted here. Now if I change this to plus plus a, here what I am saying is increment a by 1, that is fine, but when to increment? It should be incremented even before substitution. That means the current value of a 11 is placed here, and then that is assigned to b. Now let's compile. Now you can see that the value of a is 11 here itself, but the value of b is 11. In the previous case, the value of b is 10. Now here the value of b is 11 because we asked it to be incremented before. And that's the difference. Now if we say minus minus a, can you guess what is the value of b? It is 9 because a is decremented even before expression evaluation. Now let's say what is the outcome. Now you can see both a and b are 9. Now what is the value of a minus minus? Now just guess, current value of a is 10 and a minus minus makes it 9, but when a is decremented after substitution, that means a becomes 9 anyway, but the current value of a, that is 10, that is placed here. Now you will see that the value of b is 10. Now you can see the value of b is 10. Now that is the usage of the increment and decrement operators. We will use it, and while we use it you will understand this much clearly, but anyway for now this is what it is. Now let us go through the various operators available in C language. Normally in the expression a plus b, plus is the operator and a and b are the operands. Based on the number of operands, we can also classify the operators such as unary, where uni stands for 1, and these operators operate on only one operand. So that is, examples are plus a, minus a, not a, etc. Now if you look at it, there is only one operand in this expression. And binary, where bi stands for 2. So binary operators operate on two operands, a plus b, a minus b, examples. And then ternary operator, which is also called as a conditional operator. This is a very special operator introduced in C language. And this has three operands. First one is the condition, and followed by question mark, and followed by the expression, which should be evaluated when the condition is true, and colon followed by the expression, which should be evaluated when the condition is false. Now because there are three operands, so we call it a ternary operator. Now if you look at this example, the value of a is 10 and b is 20. Now the condition is something like this: a is greater than b. Now this condition is true, then a will be the result, otherwise b will be the result. Now here 10 greater than 20 is false, so b will be the end result of this expression, and then b is assigned to the variable c. And because there are three operands, we call it a ternary operator. Now the classification based on the operation performed is arithmetic operators, where they perform the arithmetic operations. So examples such as plus, minus, slash, asterisk or star, modulus, they fall under the arithmetic operators category. So here a plus b is 13, a minus b is 7, a slash b is 3 because only integer part is taken, and a times b is 30, and a mod b, which is the remainder, which is 1. So these are the basic arithmetic operators, along with increment and decrement operators, plus plus and minus minus. Now relational operators, they actually perform or evaluate the relationship between two operands. Now here are the different relational operators available: equal to, not equal to, greater than, less than, greater than or equal to, and less than or equal to. Now if you look at this expression, a is 10 and the value of b is 10, a equal to b is true. In C language, when there is a result true should be returned, the corresponding value will be 1, because there is no specific boolean data type in C language. So the value will be either 0 or 1. Now here a equal to b is true, so 1 is the end result. A not equal to b is false, so 0 is the result. A less than b is false, 0 is the result. Greater than b is 0, a less than or equal to b is 1 because it is equal to, so both are equal, and a greater than or equal to b is also true because they are equal. Now these are the relational operators. Now coming to logical operators, they are used to combine or evaluate the logical value of the expressions. Now and, or, and not. So a less than b and a less than c. So this is how we can combine the expressions, and both the expressions should be true for the entire expression to be true. And or, in case of or, so either one of the expressions should be true, and in case of not, the expression, if it is true, then return will be false. If it is false, then result will be true. Now consider this case: a is 10, b is 20, c is 30. A less than b and a less than c is true, so 1 is the result. A less than b or a less than c, so which is also true because a is less than b, that should be enough. Not of a less than b, because a less than b is true, not of a less than b is false, so the result will be 0. So there is one special property of logical operator that you need to understand. That is the short circuiting nature of AND and OR. So what AND does is, AND doesn't evaluate the second expression if the first expression is false, because the end result of the expression itself is false. Whereas in case of OR, the opposite will be the case. That is, if the first expression is true, then OR will not evaluate the second expression. Now carefully look at this example and see what is the outcome of this. A plus plus greater than 0 and b plus plus greater than 0. Because there are two plus plus operations, normally we can think that A will be incremented to 1 and B will be incremented to 1, but that is not the case. Why? Let us see this. A plus plus means post increment, so the value A is incremented later, but the current value of A is placed here. The current value of A is 0. 0 greater than 0 is false, so the entire result will be false and will not evaluate the second expression. Because B plus plus is not evaluated, B won't be incremented. That is, B will remain as 0, whereas A will become 1. So that is the end result of this expression. So value of C will be 0 because the expression evaluated to false. Then there are bitwise operators, because as the name indicates, they operate on the individual bits of the operands. Now they are AND, OR and XOR and complement. So this ampersand has multiple meanings in C language. So when it is a double ampersand, it will be considered as an end of logical end. When it is prefixed before a variable, it gives you the address of that particular variable. And when it is used in between two variables, it will perform the bitwise AND operation. So contextually, you need to understand where it is placed. Based on that, you will understand what will be the operation. Now here, AND, bitwise AND and bitwise OR, this is the pipe symbol. Bitwise XOR and bitwise complement are the four operators available. So what is the end result of these expressions? Let us evaluate. So we have A as 5 and B as 6. When we say C equal to A ampersand B, this is a bitwise AND between A and B. Now what is the value of C? Now the value of 5 in binary is 101 and 6 is 110. Now when we do a bitwise AND, both the bits should be 1 for the end result to be 1. Now 1 and 0 is 0, 0 and 1 is 0, 1 and 1 is 1, and this is 4. So the value of C will be 4. Now in case of bitwise OR, 1 or 0, either one of the bit is 1, that should be enough. So the end result will be 1. 0 or 1 is 1, 1 or 1 is 1. So finally this is 7. So the value of D will be 7. And XOR, the shortcut is that if it is opposite bits, then we can say 1. If it is equal bits, then we say 0. So 1 XOR 0, opposite bits, so 1. 0 XOR 1 is 1. And 1 XOR 1, because it is an equal bit, the result is 0. So finally this number becomes 3, and that is the value of E. Now what about complement of A? This is a special case that we need to understand. When we say complement of A, now this will be wrong, because if we say A is 101, that is 5 in binary is 101, if you write it and do a complement, means you reverse the bits, zeros to ones and ones to zeros, then this would be wrong. So you need to understand what is the memory structure of A. Based on that, you have to evaluate the result. So given that A is an integer and assuming that it is having 16 bits in memory, the most significant bit or the last bit will be taken as the sign bit. The sign bit 0 indicates that this number is a positive number and 1 indicates that this number is a negative number. So if we write plus 5 in memory, so then this is how it will be. So 101 will be the last 3 bits and the sign bit will be 0 because the number is a positive number. Now when we do a complement, so all the zeros becomes 1 and all ones becomes 0. Then this is the resultant number, and because the sign bit is 1, it indicates that the number is a negative number. So what about the rest of the bits? If the number is a negative number, rest of the bits will be a 2's complement of the original number. So we need to do a 2's complement of this number in order to get the actual number, and after doing the 2's complement, again this number is reversed and a bit 1 will be added. So 101 plus 1 becomes 110, which is nothing but 6, and sign bit value is minus, so this is minus 6. Now, if you don't know what is 2's complement and all those things, we can leave this point and move forward with the rest of the things. So don't worry about this and don't get blocked. So then comes the shift operators. As the name indicates, they shift the bits. So there are two shift operators here, left shift and right shift. Left shift shifts the bits to the left, whereas right shift does the opposite task. Now, given that a value is 20, so this is how the memory image will be. Sign bit will be 0 because number is a positive number, and 20 in binary is 10100. Now, when we do a left shift by 4, a value is shifted to the left by 4 bits. That means you will see the entire number shifting to the left, and the right side bits are filled with 0. So this is the entire resultant number. So the value of B will be 320 after evaluating the binary value. And after some time you can also see that this 1, if it comes into the sign bit position, then number also becomes a negative number. Be sure about it. Now this is the left shift operator. Similarly, we have the opposite one, the right shift operator, and here in C language this is slightly tricky. Now right shift shifts the bits to the right, and what about the newly created leftmost bits? So this is filled with 0 in some compilers, but the actual standard is to fill it with the sign bit. So whatever the previous sign bit value is there, so the corresponding sign bit will be used to fill. This means if the previous number is a negative number, then sign bit will be 1. So the newly created bits will also have 1. Now because this number is a positive number, sign bit is 0. So the newly introduced bits are having 0. Now when you shift this number to the rightmost bits will get dropped. So these things will get dropped and all the previous bits will be shifted to the right. And on the left, the bits will be the previous sign bit value. So the previous sign bit is 0, so it is filled with 0. So this is what we call the right shift. Then comes the assignment operators. Assignment operators, as the name indicates, so they assign the given value to the variable. So these operators are having the least priority, so they are evaluated at the end. So you can think that A equal to B plus C, or A assigns to B plus C, where plus is evaluated first because it is having higher priority than assignment. So plus is evaluated first and then its result is assigned to A. And there is one special property of assignment operator. It actually returns the value which is assigned. So if we say A equal to B equal to C equal to 5, this means the value of 5 is assigned to C, and this results in the actual value which is assigned. That means it comes as 5 again, which is then assigned to B, and again it comes as 5 and which is then assigned to A. And the last 5 which is obtained, which we ignored, we did not assign. So this is how this expression is evaluated. And you should also understand that the associativity of assignment operator is right to left. That means if there are multiple assignment operators in the expression, the rightmost assignment operator will be evaluated first. So that means this last operator will be evaluated first, then the previous one, and then the previous one. Now when you write an expression something like this, C equal to A plus B plus C. Now there are multiple plus operations here. So here we will evaluate the left one. So first, and this result is then evaluated with the second expression. So what this means is the associativity of the operator is left to right, whereas in case of assignment, the associativity of the operator is right to left. So based on that, the expression will be evaluated. And there are few other arithmetic assignment operators, which is plus equal to, minus equal to, slash equal to, and star, and so on. Now what this arithmetic operator does is that it performs the corresponding arithmetic operation over the variable based on the right side RHS value. Now if you look at this, A is 10 and then A times A star equal to 2 means A times 2. So A times 2 is 10 times 2, that is 20. 20 is then assigned back to A, and that is how arithmetic assignment works. So it multiplies the current value of A with 2. And if you look at this expression carefully, A star equal to 2 plus 2. So what is evaluated first? Now in this case there are two operators. So one is star equal to, that is arithmetic assignment, and one is plus. Priority wise, plus is having higher priority and then star equal to is having the lower priority. Now in this case this is evaluated first, so the result will be 4, and then A is multiplied with the value 4. So that means the current value of A is 10. So finally the end result of this expression is A becomes 40. Now this expression you should write it carefully, because what is the end result of this expression? Now this is different. We have three operators here. So the priority wise, if you look at it, this is having first priority, this is having second, this is having third. So this means 10 times 2, that is 20. The current value of A is 10 based on the value here. 10 times 2 is 20. 20 plus 2 is 22. 22 is then assigned to A. So the expression is different. Be careful or be sure about it. These are the different types of operators available based on the operation. So you will see these things in the coming examples, and we will start using these operators directly within our example programs. Up to now you have seen how the basic arithmetic operators work and how the expressions are evaluated. Now let us start with some basic relational operators using an example. And here you will also understand how the branching statements work. Now here the relational operators are equality. Just remember that you need to press double equal to sign here, and not equal to, greater than, less than, greater than or equal to, and less than or equal to. To understand these things better, we will just start with a simple basic example. We need to figure out the biggest of two numbers. For that, let us start coding it. I'm going to create a new file. I will name it big.c, and as usual let us include stdio.h and main. You will come to know what are these statements in the coming lectures, don't worry. Now in order to accept two numbers, I will declare two variables. One is, let's say, int a and b. Now let us read the values of a and b. Enter a. You can write whatever the prompt that you are looking to write. So here enter a is just one way of accepting the prompt. You can also say enter the first value, enter the second value, and then scanf %d ampersand a. So read the value of a and then printf enter b, scanf %d, and then ampersand b. Now you read the values of a and b. Now you need to print the biggest among these two, and for this you can use the if statement. If and followed by a condition. So that condition is if a is greater than b. Now you know that a is big. You can say printf. Now here you can say a is big. Otherwise, that is else. You can say printf b is big. Now if you look at this statement, if the given condition is true, then this will be executed. Otherwise, this will be executed. Let's run and check the outcome of it. gcc big.c and run the program. Enter the value of a, let's say 10. Enter the value of b, let's say 20. Now you got that B is big. Now here, instead of A is big and B is big, I wanted to print the value. So I can replace this with %d and supply the actual value of A. Similarly, %d, because I know that it is an integer and the code for integer is %d, and supply the value of B. And also let's print /n, that is new line. And compile and execute this. Big, enter A, let's say 10, enter B, let's say 15. Now you see that you got 15 is big. Now this is called as a conditional branching statement. So if and followed by condition, and here you are using the relational operator greater than. Now if you want to look for the equality of these two numbers, you will use equal to, not equality, inequality, then you will use not equal to, and similarly the other things. Say for example, if I want to check for whether both the values are equal, then I might do something like this. I will say A equal to B. Now here you need to remember that you are typing equal to twice. Now if A equal to B, then you can say that both A and B are equal. Else, that means if the condition is false, then you can say that A and B are not equal. Now check this outcome. 10 and 10. Now you got that A and B are equal. So similarly, you can use the other operators to compare two values, and if is the statement using which you can actually do a conditional branching. So take a decision, based on this decision which statement to run will be decided. I'll change it back to greater than because our target is greater than. Now that you understood the if statement, we will see the variations of it. So now that you understood what are relational operators and you also understood what is an if statement, now let us understand logical operators. These logical operators allow us to combine multiple relational expressions. Now here we have three logical operators here, and here it is double ampersand for logical AND. So a combination of two expressions, this and that. And the logical OR, this is called as a pipe symbol, and we need to write two pipe symbols. Now this is called as logical OR. And logical NOT, this is for reversing the expressions end result. Now let us see if I have to do this as a logical NOT. So if I want to reverse this expression, what should I do? NOT of A greater than B. NOT of A greater than B is slightly different. What we need to do is NOT of A less than or equal to B. Greater than becomes less than or equal to if we are applying the NOT condition. Now this program will produce the same result, NOT of A less than or equal to B. So what is A less than or equal to B? It will be true when A is either less than or equal to B, and NOT of that makes it A greater than B. Now let us execute this program and see what is the outcome. GCC big.c. Now enter A, let's say 10, enter B, 20. You can see that we got the same result. So this is how you can reverse a condition using NOT. Now let us solve one more problem here. So we need to figure out the biggest among the three numbers. So let's write that program. I'll just copy this. I'll name it as big 3. Okay. So now we need to read three numbers. So let's say int A, B and C. Also read the value of C. Now we have three numbers here, A, B, C. Now we need to find the biggest among the three. So how can we do that? So how to say that A is bigger? So that is based on the condition if A is greater than B and A is greater than C. So this is how we should write. If A is greater than B and A is greater than C, now you can say that A is big. So the logical AND operator makes sure that both the conditions are true in order to evaluate to true. Now if A is greater than B and A is greater than C, then you can say that A is big. That's fine. Now if A is not big, then you have to compare B and C before you can say that which is bigger. So else if B is greater than C, now because you know that A is not big, then the biggest will be in either B or C. So we are again comparing B and C. So if B is greater than C, now you can say B is big. Otherwise, now you can say C is big. Now this is actually called as nested if. So nested if means if, else, and within else you again have another if statement. So this is pretty simple if you carefully observe. Now if this condition is true, then this will be evaluated, else, and again this entire statement will be evaluated based on this condition. Now if A is big, then this will be printed. Otherwise, so if again B is compared with C, if B is big, then it is printed. Otherwise, C is big. Now let's see what is the outcome of it. Now I will give the value of A as 10, B as 15, C as 8. Now you can see that 15 is big. It came here, 10 is greater than 15 is false. So it comes to else part, and within else, now it compares between B and C. B is greater than C, that is 15 is greater than 8. So hence this is true. So this will be printed and it comes out of the if statement. Now this is how you can actually use the AND operator. Similarly, you can use the logical operator to check if one of the condition is true. If both the condition need to be true, then you can use AND operator. If either of the condition should be true, then you can use OR operator. And if you want to reverse the condition, then you can use NOT operator. Now let us solve a simple problem. Here you need to accept the quantity and rate per unit and calculate the amount. And you need to apply 10% discount if amount exceeds 500 and display the net price. Now let us solve this problem. I'll just call it discount.c. Now we need to accept two values and you need to calculate the amount. I will take these values as double, quantity, rate per unit I will simply call it as RPU, rate per unit, or rate per item, whatever it is. And for calculating the amount, I'll just take another variable called amount. Now we took three variables. Now we need to read the values of quantity and rate per unit and need to calculate the amount. Printf enter rate per unit, scanf. Now it is not percentage %d because percentage %d is for integer, d for decimal point value. Now here because we took the variable as double, we need to take percentage %lf. Now normally percentage %f, if you are going to read a float and long float, that is a double, Now use %LF when you are looking to read a double, and that is the only difference. Now read this into RPU, and then printf, enter quantity, scanf %LF, comma, ampersand quantity. Fine, we now got the values. Now we need to calculate the amount. Amount equal to quantity into rate per unit. So quantity multiplied by rate per unit. Now we need to check if the amount exceeds 500, then we need to discount it. So if amount is greater than 500, then we can give the discount, and the discount is 10% of the amount. So what we can say is amount equal to the existing amount into 0.9. So that is 90% of the amount is the actual amount. Now print the amount. Printf, calculated net amount, %LF because it's a double, and amount. We will also add /n for new line. That's all. Now let's compile this program. GCC discount.c. Now run this program. Enter the rate per unit, let's say 90, and the quantity 5. So we should not get any discount here. So the calculated net amount is 450. Now let's run the program again. Amount 90, quantity 6, that is 54. Now we should get 54 less than 540. Now this is fine. Now this statement, if you look at it, is not having else, and this is called as simple if. Simple if is just the if statement without else part. That is fine. So if you look at the execution of this program, the statement gets executed and it prints the prompt, and when this statement gets executed, it reads the value into RPU, and this prints the quantity, and this particular statement reads the quantity, and this calculates the amount, and this statement will be executed only if the amount is greater than 500. Now if you look at it, if is one of the statement, and the execution of this is dependent on the condition, and once it is done, whether irrespective of whether this statement runs or not, control comes to the next statement and it prints the calculated amount. So the only condition here is, in order to execute this statement, this condition should be evaluated to true, and this is what we call as simple if. So we have seen three variations of if: simple if else, and nested if. Nested if is if inside another if statement. So here I am going to show you what is a block. I am just creating a file, block.c. Now I'll just read what is the weekday. Let's say weekday. Printf, enter weekday, 0 for Sunday, 1 for Monday, etc. Now scanf %d ampersand weekday, and now here I want to print enjoy weekend only if the weekday is Sunday or Saturday. So for that, what I'm going to do, I'll just say if weekday equal to 0 or weekday equal to 6. Then I want to just printf enjoy and printf weekend. Now let's see what happens here. I'll just compile this program, gcc block.c. Now enter the weekday. I will say Monday. But if you see, you got weekend, and this is because the statement gets executed irrespective of the condition. Now weekday, what we have given is 1, but weekday equal to 0 or weekday equal to 6 is wrong. So if condition failed, but still you saw the weekend, and this is because if statement controls only the immediately following statement, and here the immediately following statement is printf. Now the next statement doesn't come under if. So the only statement which is controlled by the condition is printf enjoy. Now if you want to combine both the statements, you just need to put them under the block, and this is called as a compound statement. So now you grouped both the statements into one single statement, so using the block. Now if is followed by the statement, that is the compound statement, that is the block, and this entire block is now controlled by this condition. Normally when you write a statement, you look at it as two different statements. Now when you put this inside a block or braces, you are making it one single statement, that is the compound statement. Now if and followed by condition, this immediately takes the following statement. That means this executes this statement based on the evaluation or based on the result of this condition, and it picks only the immediately following statement. So if you want to combine multiple statements, you just use the block. This is a very simple scenario. So if you look at it, if you think that you have multiple houses here, now if you look at it, then you will see that there are two buildings here. Now if assume that this entire building is combined inside a simple compound wall, now then this becomes a campus. Now that is for your easy understanding. So block combines multiple statements into a single statement, and if statement immediately picks the following statement. So even this is called as a statement, is called as a compound statement. Now make sure that whatever you write, if you are using if else, if followed by condition, then statement 1, else statement 2. So statement 1 is executed if the condition is true, otherwise statement 2 is executed. And you can mix and match the if condition inside the if condition to get the desired results. There is one other interesting statement called switch statement. It is similar to if statement, but sometimes it makes it more readable. So let us understand that with an example. Similar to this one, so we need to print the weekday for the given day number. Now let me write a new example here. .c. Now here I am accepting the weekday, and now I just need to print the actual weekday for the given number. Now if you are looking to print it using the if statement, you will be doing something like this. If weekday equal to 0, printf Sunday. I'll also add /n. Else, this block is not required when there is a one single statement inside it, but usually it is a good practice to put the block. Now if weekday equal to 0, then we print Sunday. Else, it's not simple else. If again weekday equal to 1, then we print Monday. else if weekday equal to 2, then we print Tuesday. And this is how we do for the rest of the statements as well. Now, instead of writing the statements like this, we can also replace it with the switch statement. And this is how it is. Switch weekday. Now, case 1. Now, this means that in case weekday matches with 1, then this is what you should do. Printf Sunday. Case 2, printf Monday. Now case 3, printf Tuesday. And similarly you write for all the other cases. Now if none of the cases matches, optionally you can also put the default. Default is actually optional. Default is executed only when no other case matches with the expression. Now in the default I will just print invalid weekday. Now let's run and see. So what is the outcome of this program? GCC switch.c. This compiles the program. Now /a.out. Now enter the weekday. I will say, I'm sorry, we need to correct this. 0, 1, 2. We need to compile the program again. Switch.c. Now a.out. Now let's enter the weekday. I will say Sunday, 0. Now if you look at it, it printed everything. And this is the point that you need to note while using the switch statement. Whenever a particular case matches, say for example, I'll give Monday. Now you see that you got Monday, Tuesday and invalid weekday. And this is because weekday matches with 1 and it printed this one. And also the default nature of the switch statement, it continues to execute the rest of the statements till there is a break statement. Now if there is no break statement, it will continue with the rest of the cases, and it is also useful at times when we are writing some logic which is applicable for multiple cases. Now here what you missed is the break statement. Break terminates the switch statement. So once the particular case gets executed, the break will take the control outside the switch and any statements that follow the switch will get executed. Similarly, for case 1, we need to break it. Case 2, and default doesn't require a break here because we have written it at the end, and anyway there is no statement that continues the default here, so we don't need a break. Now let's run and see what is the outcome of this. Before that, compile. Now you see you got only Sunday. Similarly, now you got Monday. Switch statement is also similar to if statement. So you can give the expression here and you can write the cases based on the equality of this expression. If expression matches with this value, the corresponding case gets executed, and break is actually optional. So compiler doesn't give you any warning if there is no break, but not having break implies that the following case will also get executed till there is a break statement. Now it is always important to note that we need to put the break statement at the end of the statements. So break will take the control out of the switch statement, and whatever the subsequent statements present in the program, they will get executed. We will see in detail how to use these things through the examples that come in the following lectures. Before we can start solving the problems, you need to understand what is a while statement. Now, it is called as a loop or iterative statement, and C language supports three iterative statements: while, do while and for. Now let us start with while. Now I will start with a simple example so that you can understand this easily. I'll call it while.c, and as usual I will include stdio and this main. Now let's suppose I ask you to print hello. You will do hello, something like this. Now I ask you to print it for 10 times. You may say that you will repeat this statement for 10 times. And what if I ask you to print this hello for 100 times? You might have to repeat it 100 times. You don't need to do that. You can repeat the same statement for 10 times, and for this you have a construct called while. Now I'll say I'll put this printf under the while statement. Now while the condition is true, let's say count is less than or equal to 10, it's fine. And it is always better you can indent it so that the code is more readable. I am pressing the tab character here to take the printf slightly away. That's fine. Now while count is less than or equal to 10, printf hello. This looks good, but what is count? We need to declare the variable count. I'll say int count. So what is the initial value of count? I will start with 1. Now while count less than or equal to 10, this will print hello. But when the count will become 10, because we didn't increment the count, so that is not going to become 10, and this will print infinitely. Now it is better we need to, once we print the hello statement, we need to increment the count. So count equal to the existing value of count plus 1. The existing value of count is 1, and 1 plus 1, then count becomes 2. But unfortunately, while will take only the immediately following statement. The second statement doesn't come under while. So in order to do that, we need to put both the statements inside a block. Sometimes you see that people writing the block like this. That is fine. Both ways it is fine. Now for me, I personally like this approach. Now this block means all the statements come under a single statement, and while will repeat it. So let us trace what happens here. While count less than or equal to 10. So what is the initial value of count? That is 1. 1 less than or equal to 10 is true. So this comes inside, prints the hello statement. Now count becomes 1 plus 1, that is 2. Now while looking at these expressions, you need to understand that the right hand side will be evaluated first, and then its value is assigned to the left hand side variable. Now here this is 1 plus 1 is 2. Now control goes back again to the while statement, and that is the actual nature of the while statement. So once the control comes back, 2 less than or equal to 10, condition is true, it prints hello, then count becomes 3, and it again comes back, and 3 less than or equal to 10, condition is true. Like that till the count becomes 10, this statement will be repeated. Now when the count is 10, 10 plus 1 is 11, so count becomes 11. When control comes back here, 11 less than or equal to 10 is false, and while will stop repeating this statement, and control will come here, and whatever is present here will get executed. So while statement allows you to repeat this statement as long as the condition is true. Now in C language, a true means any positive value, that is 1. I will explain you in detail the technicalities behind it later on. Now let's see how it works. Let's compile the program. gcc while.c. Let's run the program. Now you can see that hello gets printed some 10 times. Now if I want to repeat this statement for 100 times, I simply need to do 100 here. That's it. Now let's understand what is a do while statement. But don't worry, even if you didn't understand these things clearly, once we start working on the examples, you will be able to easily understand them. Now here, just like while, do while also repeats the statement. The only difference is it is called as an exit control statement. Control will come back to the initial part of the statement only when the expression is evaluated to true. If the expression is evaluated to false, then it comes out of the statement. What is the difference between while and do while statement? Now let me ask you a small question. What if this expression is false initially itself? Then while statement is not executed. This particular statement won't get executed because expression is false and it will immediately come out of it. But because in the do while statement, expression is evaluated at the end, even if the expression is false, at least once the statement gets executed. Okay, so we will look at it later on, but anyway, let us do a simple example on it. Just like while statement, I'm going to copy this. I will rename this as do while. Now, how to translate this while statement to do while statement? It's pretty simple. The while statement, the expression here should come at the end and followed by a semicolon because you need to end the statement. And initially, you just put do. Now that's all. This becomes do while. So do, and the statement gets repeated as long as this expression is evaluated to true. Now initially count is 1, it comes inside, prints hello, count becomes 2, 2 less than or equal to 10 because condition is true. Now the control again goes back to do statement and again repeats this part, and it goes back as long as this condition is true. Once count becomes 11, 11 less than or equal to 10 is false, and this control comes out of the do while statement. Now that's it. So it's pretty simple. We will see in detail in the future examples, but for now just execute this. I think I modified the wrong one. Let's go to the do while. We'll keep it here and do. That's all. Now let's compile and execute this program. GCC do while.c run. That's all. Because we said 100, so it printed it 100 times. Now if you put /n, and I will also remove this, make it 10. You see it got printed 10 times. Now let's quickly understand what is a for statement. All three statements, while, do while and for, all three are almost same. They repeat the statement as long as the condition is true, and once the condition is false, they'll stop repeating the statements. Now the only difference between while and for is that we have all initialization, condition and increment combined together. Now let us see that in the example. You will be able to understand this easily. I'm going to copy this again. So now let me convert this into a for statement. So instead of while, I am keeping this as for. Now initialization, we have done the initialization here. We don't need to do that. We may do that as well, but we can also do it here. Count equal to 1 and followed by a semicolon, so that it terminates the initialization, and then followed by a condition, and condition is followed by increment. So here the increment is count equal to count plus 1, which can be done directly here. And this becomes a first statement. So count is 1 initially and count less than or equal to 100. This should be true in order to evaluate this statement. And then next time count becomes count plus 1. So the previous value of count is incremented by 1 and then it is assigned to the count. Now instead of count equal to count plus 1, we can simply say count plus plus to increment count by 1. And I will explain you what this operator is in the coming lectures. Fine. So if you look at the while statement and first statement includes all three. One is the initialization. So the first time, even before evaluating this expression, conditional expression, so this will be initialized to 1, and then conditional expression is evaluated every time, and only if it is true, this statement is repeated. And then finally, before evaluating the conditional expression again, the increment operation is done. So this, once the increment is done, again the condition is evaluated, and if it is false, the statement ends and control will come to the next following statement. All three statements do the same task. Their goal is to repeat the statement given number of times. It is not just about the given number of times, it may be something else as well. Something like you are looking to search for an element and the statement is repeated as long as the element is not found or we reach the end of the list. So it may be something like this. You will clearly understand these things in the coming lectures. But for now, to simplify, for, do while and while, all three will repeat the given statement as long as the expression is true. Now let's compile and see if that is the outcome. For.c. So that's it. Now let us start few problems using loops. Here is our first problem. Now we need to print the numbers from 1 to n. Now pause this video and give it a try and come back and check the results. Now here what we don't know is the value of n. So just read the value of n and then using the loop we will be able to iterate through 1 to n and print those values. So let us start coding it. First I'll create a file. I'll name it loop ex1.c. Now stdio.h will include the file and then int main return 0. This is fine. Now we will read the value of n. I'll say int n, then printf, enter n, and then scanf %d because we are reading an integer, and ampersand n to read that value into n. Now we got the value. Now the simple thing we need to do is to loop through or iterate through 1 till the value n. And for this I will take a variable called I. I can say comma I, or I can also declare it as another in the next line. Both ways it is fine. So whatever is convenient to you, you can do that. Now initial value of I equal to 1. So it starts with 1 and we will print the value of I. So now we printed I. So next what will be the value of I? I equal to I plus 1. So that means I becomes 2. We again need to print the value of I. Then I equal to I plus 1, I becomes 3. We need to print the value of I. So that means that we will repeat these statements till I is less than or equal to n. So that means I'll just put it inside a loop. I is less than or equal to n. So print the value of I equal to I plus 1. Again go back, check if I is less than or equal to n. If it is true, then print the value of I. Now let us trace this and see how it works. Let's say that the value of n is 5. Now I equal to 1, 1 less than or equal to 5, that is true. It comes inside, prints 1. Then I equal to I plus 1, so you are assigning, incrementing I by 1, that is I becomes 2 now. And because it is a loop, it again comes back here, 2 less than or equal to 5, condition is true, so prints 2. Then I becomes 3, comes back, 3 less than or equal to 5, and so on till I becomes 5. So assume I is 5 now, 5 is printed, I becomes 6, now comes back, 6 less than or equal to 5 is false, and it completes the loop and comes out of the loop and executes any rest of the statement because we don't have any. So that's the end of the program because you are returning from main. Now let's compile and check what is the outcome of this. GCC loopx1.c. Now let's execute. Enter n, let's say 5. Now we can see 1, 2, 3, 4, 5. Now just see that I have given a small space here after %d just to get this space in the output. So here is your next problem. You need to find the factorial of n. So what is n factorial? It is the product of all the numbers from 1 to n. Now let us see how to solve this problem. So I would like you to pause the video and see if you can solve it and come back and check for the output. Now here I'm going to create a new file. Let me copy this code first. I'm going to create a new file. I'll say loopx2.c. I'll paste it. Now we need to read the value of n. This is same. So because we don't know what is the value of n. Now once we read the value of n, we need to find the factorial. So last time we printed the numbers from 1 to n. Here we need to calculate the factorial. We should not print it. Now how to find the factorial? So for that I will take one more variable. I will name it fact, and then the simple expression fact equal to fact into I. So fact equal to fact multiplied by I. Now let us trace this program. So let us say I equal to 5. Now I equal to 1. 1 less than or equal to 5 is condition is true. Now come inside. So fact equal to fact into I. So the existing factorial value into I, where I is 1. Now what is the existing factorial value? We did not give any value, so this is wrong. So the first value of fact, we cannot keep it 0. Please remember that 0 into I is 0. So the initial fact is 1. Now evaluate this, I equal to 1. So I is 1, 1 less than or equal to 5, condition is true. Come inside, fact equal to fact into I, that is 1 into 1, which is 1. And now I equal to I plus 1, I becomes 2. Now loop ends here and again comes back to while statement, 2 less than or equal to 5, condition is true. Come inside, fact equal to fact into I, that is 1 into 2, that is 2. Now I becomes 3, 3 less than or equal to 5. I'll show you diagrammatically how this works. But before that, so after the loop, fact will contain the factorial value. You just need to print the value of fact. So factorial of %d, that is n, is %d. So I'm now printing two values. First one, factorial of n. So the value of n, I will pass it as first argument, and then fact as second argument. So that means first %d is replaced with the value of n, and the second %d is replaced with the value of fact. Now I will also put /n. Now let us check what is the outcome of this. First compile loopx2.c. out. So n is 5. You should see the factorial of 5 is 120. Now let us trace how this works. So the first part here, so the value, we declared three variables n, I and fact. So that means we got three memory locations n, I and fact. So I'm just drawing it slightly bigger one. Now fact is initialized with 1, that means the initial value of fact is 1. Now printf enter n, so you got the prompt enter n. Now it is waiting for value, scanf, you are going to read a value that is an integer, %d, and you are reading it into n. So that means the value 5 is placed in n. So that means here you got 5. Now I equal to 1, so the value of I is 1, while I less than or equal to n. So just remember that this is your condition, I less than or equal to n. The value of I is 1, 1 less than or equal to n, that is 5, true, comes inside. Fact equal to fact into I. So first evaluate the right hand side, that is 1 into 1 is 1, so which is same. Now I equal to I plus 1, so that means I is incremented by 1, so which makes this value as 2. I am drawing here. Now loop comes back, 2 less than or equal to 5, condition is true, then fact equal to fact into I. So the initial value of fact is 1, 1 into 2 is 2, so which is then assigned to fact. Now I equal to I plus 1, I becomes 3. Now 3 less than or equal to 5, condition is true, fact equal to fact into I. So existing value of fact is 2, 2 multiplied by 3, that makes it 6. Then I becomes I plus plus, I equal to 4. Then 4 less than or equal to 5, condition is true, fact equal to fact multiplied by I. So that is 6 multiplied by 4 makes it 24. Then I plus plus, I becomes 5. 5 less than or equal to 5, because it is equal to, it is true, comes inside. Fact equal to fact multiplied by I, that is 24 multiplied by 5, which is 120. Then I plus plus or I equal to I plus 1, so that means this becomes 6. 6 less than or equal to 5, false, comes outside and prints this output. So the factorial of what is n, that is 5, is fact, that is 120. Now you can also solve this using the for loop, it is up to you. Now because this is while, you have initialization here, condition here, and increment or decrement here. Now if you want to write it through for loop, you can simply say for I equal to 1, I less than or equal to n, I equal to I plus 1. Now then you don't need this here, because you are already having increment at this point, and you don't need initialization here because we are already having that. So both are same. Now here we are having initialization, condition and increment, and this is separated by semicolon. So let's see if that is same. Yes. Yeah. Okay, let us solve one more problem. So you need to find the sum of the digits of the given number. So let us say I have given a number 982, then you need to find the digits. So 9 plus 8 plus 2. And for this, the hint is you need to use the modulus operator. Modulus operator 982 mod 10 gives you the last digit, and 982 slash 10, so that makes it 98.2. So if you take only integer part of it, So you can cut the digit. So take it as a hint, give it a try, and come back and find the solution. So I'm going to create a new file. I'm going to call it loopx3.c. So int main and return 0. Now let us read some n. So let us say int n, printf enter n, scanf %d, and read that into n, that is ampersand n. Now we got the value of n. So what we need to do is to find the digits sum here. So I will say I'll take another variable, that is sum. Now sum equal to sum plus n mod 10. Now if I say n mod 10, given that n is 982, let's say, so n is 982. What is 982 mod 10? That is 2. So you are adding that to the value of sum. So what is the initial sum? You cannot take it 1, that's not fair because you are adding 1. So you should take it as 0. Now if you take it as 0, now 0 plus 982 mod 10, that is 2. So 0 plus 2, which is 2. Now next time when the same statement is repeated, we need to get 8 then. So how can we get that? If I say n equal to n slash 10, now what is n? 982. 982 slash 10 is 98.2, because n is integer and 10 is integer, we will get only integer part of it. That makes it 98. Now if you go back to this statement and see what happens. Now the current value of sum is 2. 98 mod 10 is 8. 2 plus 8 is 10. Now if you come back here, 98 slash 10 is 9.8, and take only integer part of it because here the expression is evaluating to integer. So that is 9. So n becomes 9. When you go back here, 9 mod 10 is 9. So 10 plus 9 is 19. Now n equal to n slash 10. So 9 slash 10, which is 0.9, that is 0. Now we can stop. So this means both these statements can be repeated as long as n is positive value. So while n is greater than 0, so find the sum, cut the digit. Again, if n is greater than 0, find the sum, then cut the digit till n becomes 0. And finally, when you come out of the loop, just print sum of digit c's, %d, and sum. You'll also include slashing. Now let's see if we are getting the right expected result. This is C, loopx3.c, 982, and the sum of the digits is 19. So here you go. So we are going one level inside. Now your target is to print this kind of output. Now here you need to print 1 for first row, 1, 2 for second row, 1, 2, 3, 1, 2, 3, 4, like that. So you can also do it for given n rows. Now this requires 2 loops, one to actually change the value of let us say row number 1, row number 2, row number 3, row number 4, like that. And you need a loop inside another loop that goes till the row number and prints these values. Now that is the hint. Give it a try and come back and check the result. Now I'm going to create a new file. I'll name it loopx4, as usual, include stdio.h, int main, return 0. Now, so I'll take a variable, I will say int row, and also I will add another variable called column. Now let us assume that the row is 1. Now what you should do here, so column value you should actually change from 1 to the row number, so that is 1 to 1, and you print the value. Now here I'll take column equal to 1 and while column less than or equal to the row number, just repeat this, column equal to column plus 1, and we will print the value of the column, so that is printf %d column. Now here what you are doing is, you started with row 1, then you are writing a loop that repeats from column 1 to the given row number. So column will be 1 and 1 less than or equal to 1 is true, and then it prints 1, column becomes 2, 2 less than or equal to 1 is false, so loop terminates. Now row is incremented by 1, so row equal to row plus 1 or simply row plus plus, both are same, and we will go back and repeat the below steps till row less than or equal to 5. Let's say 5 for now. And I will explain you what's happening here, but for now just check that row is 1, 1 less than or equal to 5 condition is true, then column will move from 1 to the row number, so 1 to 1, and it prints the value 1. Now next time row plus plus row becomes 2, 2 less than or equal to 5 condition is true, again column moves from 1 to 2, so that is first time 1, it prints 1, next time 2, it prints 2, and row plus plus row becomes 3, 3 less than or equal to 5 condition is true, column again moves from 1 to row, that is 1 to 3, and it prints all the 3 digits. So similarly it goes till row equal to 5, and after the end of each row I will print a new line character so that the next record will go to the next row. So printf /n. Here because we don't have /n, it is printed in the same row. So once the row printing is over, then we are moving to the next row. So we will see how this works, but anyway, let's see what is the outcome of this. Now you can see that we got this output. Now let us see how this worked. So before that I will also change it, instead of simply 5 I will actually put it n, and I will read the value of n. So before that, declare the value of n, declare n, printf enter n, scanf %d %n. Now this means that you can control the number of rows that you want to print. So compile, run it. Now I want to print only 3 rows. I can say n is 3, so row number moves from 1 to 3. Now let us see what has happened here. Now if I write something like this, for row equal to 1 to n, for column equal to 1 to row, print column. And this is what we did inside these while loops. So the first time when row equal to 1, column equal to 1 to row, that is 1 to 1, and we printed the value of column. Second time when row equal to 2, column equal to 1 to row, that is 2. So second time we printed from 1 to 2. Third time when row becomes 3, column equal to 1 to 3. Now if we change this program to a for loop, maybe it will be more easy for you to understand. So for row equal to 1, row less than or equal to n, and row plus plus. So I don't need this statement here. Now inside this for loop, for column equal to 1, column less than or equal to row, column plus plus. Now we don't need this one. Now see what happened. This is same as the previous one, but this looks more readable. So you try to trace it with values, you will be able to understand this easily. Okay, so this is your next example. So you just need to print this kind of output similar to the previous one. See if you can do it. I'm confident that you can do it. So let's give a try. Now for this I'm going to create a new file. So I'll copy this code. Loop example 5. Do you know what you need to do? Yes, it's a very simple one. Change. Maybe initially, if you are an absolute beginner, maybe you might find it slightly difficult. No issues, but give a try and keep on trying. So that's the only way you can understand. So if you can trace it with variables and values, and once you break this jinx, you are there. You will be a very good developer. Now here I just need to print the row number. That's all. Now here when the row number is 1, just print 1. When the row number is 2, print row number 2 twice. When row number is 3, print row number thrice, like that. That's all. Now see if we got the same result. GCC loop ex5. I'll say 4. See that we got the outcome. Alright, so here is the next problem that you need to solve. You need to check whether the given number is prime or not. Now a prime number is divisible by 1 and itself. So there should not be more than 2 factors for the number. So that is 1 and itself. Give a try and then come back to check the solution. I'm going to create a new file. I'll name it loop example 7. Okay, so include stdio.h main return 0. So all are same. So first of all we need to accept a number. So I will say n. So let's say int n, printf, enter n, read the value of n. Now here you need to check whether the given number is a prime number or not. Now in order to check that this is a prime number or not, we need to divide this number with all the numbers from 1 to n, and we will see if there is any factor, and we will increment the factor count, and based on that we will say that if it is prime or not. So first what I will do, I will create a variable, say I, and also count. Count actually holds the factor count. Now let's assume that the factor count is 0, and we have so many different versions of this program, so don't worry. So let us first go with the very simple approach. So count is 0, so count will hold the number of factors. Now let us start with I equal to 1 and go till I is less than or equal to n. Yes, each time increment the value of I. Now we need to check if I is a factor of n or not. Now if I is a factor of n, so how can we say that? So we can say that when n is divided by I, the remainder should be 0. Then I can say that that is a factor. Oh, now I will increment the count. I found the factor. I will increment the count. Finally, at the end of the loop, count will be the number of factors found for n. Now, if count is equal to 2, then we can say percentage d is prime, that is n. Else, we can say percentage d is not prime. Now first check the outcome and then we will evaluate. Now enter the value, let's say 10. 10 is not prime. I will put /n. I'll say 10. You see that 10 is not prime. Then run it one more time, let's say 7. You can see 7 is prime. Now we will evaluate and see what happened here. If you understood, move on to the next lecture. Otherwise, just see the evaluation. Okay, so let's start. Now we have three variables here, n, I, and count. Okay, so let's say the n value, let's suppose the value of n is 5. Then count is initialized to 0. So we got 0 here. I is initialized to 1. Now 1 less than or equal to 5, condition is true, comes inside. 5 mod 1 is equal to 0. Correct, because 5 when divided by 1, the remainder is 0. So count gets incremented. So count becomes count plus plus means count becomes 1. Now I plus plus, I becomes 2. Now go back to the start beginning of the loop. 2 less than or equal to 5, condition is true, come inside. If 5 mod 2 equal to 0, is 5 mod 2 equal to 0? No, because the remainder is 1. So because only when the condition is true, then the count will be incremented. Because it is not true, so it will not be incremented and there is no else part. It's a simple if. This is incremented only if this condition is true. Now I plus plus, I becomes 3. Now 3 less than or equal to 5, yes. 5 mod 3 is equal to 0. No, because the remainder is 2. So I plus plus, I becomes 4. Now 4 less than or equal to 5, true. 5 mod 4 is equal to 0, no, because the remainder is 1. Next, I plus plus, I becomes 5. 5 less than or equal to 5, condition is true, yes. 5 mod 5 is equal to 0, yes. So count plus plus, count becomes 2. Now I plus plus, I becomes 6. 6 less than or equal to 5, condition is false. So loop terminates, it comes out. Now here we are checking what is the count, because count holds the factor count. Now the number of factors for this number is equal to 2. Then we say that it is prime. Because it is equal to 2, now percentage d, that is replaced with n. So n is 5. 5 is prime. Now similarly, let's say n is 6, then what will be the count? So for 1 it gets incremented, so that count is 1, and for 2 this gets incremented, so that is count is 2. Now for 3 this gets incremented, so count is 3. Then for 4 and 5 it is not incremented, and for 6 this gets incremented, that is 4. So when you come out of the loop, the count will be 4 and else part gets executed and it will print the value is not prime. Alright. Now let us understand what are functions. Functions for few people seems to be a difficult concept, but in my opinion it is simple and very straightforward. Now you might have seen a simple mathematical function something like this. So big of x comma y, x if x is greater than y, y otherwise. That's all. Now this is a simple function definition, and while calling this function or invoking or using this function, whatever you want to call, now you will be calling it with something like this. So big of 10 comma 20, where 10 is the value for x and 20 is the value for y. Now you know what is the result of it, because if x is greater than y, no, so y is the result, that is 20 is the result of this expression. Similarly, this can be translated into a simple C language function as well. Now let us see how to write it. So I will create a new file. I will name it function ex1.c. I just created a blank file. Now let us define and replicate this function and see how this works. Now you may think that the big is, I will retain the same name, x comma y. But here in C language or normally in many programming languages, you need to specify what is the data type for x or what is the type of value that you are expecting for x. Now you can think that this is for an integer, and then what is y. And this is important because each parameter, so that is x, y, they may vary in data type. So we need to specify the data type for individual parameters. Now here the x and y are called parameters, and whatever you supply are called arguments. So here 10 and 20 are called arguments. Now is big is going to return something? Yes, big returns x if x is greater than y and y in other case. So what is big returning? It is returning either x or y, but from the data type perspective, what is big returning? Big returning an integer. So the return type is defined just before the function. So here big takes two parameters, that is x and y, that is two integers, and it returns an integer. So this is similar to this definition. And then you begin the function block. This is what you should do when somebody invokes big. So here you will put all the logic what need to be done when somebody calls the big function. Now here this is a simple if statement. If x is greater than y, I will return x, otherwise I will return y. That's all. So now you replicated the same function here in C language. Now let us see how to make a call as well. So here I am going to declare a variable called z, big of 10 comma 20. Now here we are making a call and with arguments 10 and 20. So 10 is the value for x and 20 is the value for y. Now based on this call, actually control comes from this part to here. It executes this block and returns with the result. Now the result is 20 anyway, you know. Now let us print that result. Result is %d and z. Now that's all. Now let us compile and execute. Now you can see the result is 20, and this is how you can replicate a simple mathematical function in C language. I'll tell you more about the functions in the coming lectures, but anyway, for now, consider that this is the definition and this is the function call, and x and y are what we call parameters, and 10 and 20 are arguments. Now, whatever the logic that you want to execute when somebody calls the function, that will be inside this block. Now you can relate it to the main. Even main is a function, and this is what we do when somebody calls main, and inside the main we are making a call to big, and we are getting the biggest value, and then we are making a call to printf and returning. So you can see that there are two functions in this program, big and main. Main is the first one to be invoked. So now that you know what are the functions, how we make a call to the function and other things, now let us analyze and how we can identify the data types for the functions. In this example, I have given you two simple functions which are independent. One is g of x, which is nothing but x times 3 for the given value of x, which belongs to z. So z is nothing but it's an integer. Now f of x equal to x times g of x minus 1 and times 3.2 or 3.2, given x is integer. Now we need to print the values of f of 5 and g of 2. Now in this example, I have placed a few blanks so that we can identify what are the data types which need to be selected here, and we will see how this execution flow happens. Now first thing is, let us come with g of x. Now when we say g of x is x times 3 for all x belongs to z, here x is an integer. Now in this example I didn't use the exact function notations, just because I am not truly concerned about it. These expressions are just for your understanding purpose. You know that z is an integer and x belongs to integer. Those things should be fine, more than enough. Now what is the data type for x in g? Now in function g, the x as the type indicates that it should be an integer. So I will place the data type for x as integer. Now this is fine. Now what is the type of value that we will be returning? Which is nothing but x times 3, and which is also an integer. So the return type for g is also an integer. Now this is good. So now let us come to f of. So in the function definition f of, what is the expected data type for f of? That is also an integer. This is fine. Now what is the return type for f of? What is the type of value that it will be returning? Now x is an integer, g of x minus 1, the result will be an integer, so no issues. But what is 3.2? 3.2 is a double. Now this means the entire expression will be evaluated to a double. Now that is your decision. Now what is that you want to return? If you want your function to be more precise, so the return type should be double, because the type of value that we will be returning is a double value. Now based on this, what should be the data types for a and b? So what should be the data type for a? So here f of is a function call, and what is the return type for f of? Which is a double. So the return type for f of is double, so what should be a? A should be a double. Okay, then so what about b? What is the return type for g of? G of returns an integer. So what should be the data type for b? Which is an integer. Now what are the codes to be used? Here a is a double, so we should be using percentage %lf. Now whereas for b we should be using percentage %d, because it is an integer. Now let's understand how this works. So the first instruction to be executed is this one, and the second instruction is this one. Now this actually creates a variable in memory, but its value need to be initialized, and in order to initialize there is a function called to f of. So the control comes here and it creates a variable called x, which the value passed to the function as argument. So what is the value? Which is 5. Now the fourth instruction is return x times g of x minus 1 times 3.2. So what is x minus 1? That is x minus 1 is 4. Now there is a call to g of with argument 4. Now unless g of 4 is evaluated, we cannot evaluate this expression. So the next statement to run will be the function call g of. Now here there is another copy. This is different. Here there is another x gets created, which is local to g of call. Now the value 4 is passed as argument. Now the next statement to be executed is return x times 3, that is 4 times 3, which is nothing but 12. And when the function call is completed, all the local variables created as part of that function will get destroyed. So that means the x which got created here gets destroyed, and the return value 12 is placed in place of the call. So the next instruction to be executed, after 7, the 8th instruction to be executed is this one again. So the current value of x is 5. 5 times 12, that is 60. 60 times 3.2, that is 192.0. Now, because the function is completed, so the local variable x which got created earlier gets destroyed. Now the function returns with the return value 192, which is placed here, and the value of a will be 192. So that is after 9, the instruction to be completed is 10, which actually assigns the value, and then the 11th instruction is this one. Now here b gets created and b need to be initialized, and in order to initialize b we are making a call to g of. That means the next instruction to be executed will be g of. Now here again, after 11, this will be the 12th instruction. Again x gets created here, which is a different one than the previous one. Now the value of x is, because we are passing 2, the value of x is 2. Now x times 3, which is 6. So this is the 13th instruction and the 14th instruction. And because we are returning with the value 6, the local variable which got created now will be destroyed, and the 15th instruction will be this one with the value 6, and then it is followed by the printf call. Now again the 17th instruction execution will be the printf function itself, which is part of the library, and then I'm just assuming that that is present. Let's say the printf function is there as part of library. Now the 17th instruction will be coming from this function call, and then 18th instruction is coming back to this function, and 19th instruction will be coming from this function call. And once they are done, main is completed. So let's say this is 20th instruction. So once the main is completed, the local variables created as part of the main also gets destroyed. And this is how the execution flows. Just make sure that you understand this or repeat it if you didn't. So here is the problem that you have to solve. You need to define a function fact that accepts a given integer and returns the factorial value of the given integer. Now, if you are not sure of how to calculate the factorial value, please follow my previous lecture where I explained you how we can calculate the factorial value. Now give it a try and come back for the solution. I'm going to create a new file. I'll name it function ex5.c. Now we should be defining a function called fact that accepts an integer. I'll say n. Now this function should calculate the factorial of the given n and it should return that value. Now how to calculate the factorial of the given n? So here I'll take a variable called I and I'll call it f. It is initialized to 1 and we will start with 1 for I equal to 1, I less than or equal to n, I plus plus, and we just need to multiply f with the corresponding I. So f equal to f multiplied by I. Now let's say n is 5. So let's see how it works. Initial f is 1. So 1 multiplied by 1 is 1. Then I becomes 2. 2 less than or equal to 5 true. 1 multiplied by 2 is 2 and so on. So this, if you evaluate, after the end of the loop, f will contain the factorial value. And I just need to simply return f. So whoever is calling the function fact, they will receive the value of f for the given number, which is nothing but the factorial of the given number. Now f assigned to f multiplied by I can also be replaced with f asterisk equal to I. This is called as arithmetic assignment, where the value is multiplied with the current value, so the RHS value. So the existing value of f is then multiplied with I and then it is reassigned to f. So plus equal to, minus equal to, asterisk equal to, and so on. You can use the respective operator in order to replace this kind of expressions. So now I will again declare n, enter n, scanf %d %n. Now you just need to pass on this value to the function fact in order to get the factorial. So printf factorial value of %d is %d. Now first value I will give n and second value I will make a call to fact and I will supply n. Now here I am making a call to the function fact with the value of n and this will be received by this variable n. Now in this context, if you see, here I am declaring a variable n and here I am declaring a variable n. Both are different. So this is local to this block and this n is local to this block. Both are different, don't worry. So each has its own copy. I am introducing you two different terms here. So first thing, I am making a call inside the printf. Don't worry, just like the nested function calls, this is an outer function and this is an inner function. Inner function call is evaluated first and then the outer one. And also I introduced you to arithmetic assignment. And the other thing is, here I declared a variable n and here I declared a variable n. Don't worry, both are different. So this is local to this block, whereas this n is local to this block, so both are different. So it is almost analogous to somewhere like you have a state or a city name within one country and the same name is present in another country. So they both are different, no matter whether their names are same or not. So now let us see how this works. Compile the program, function ex5.c. So let's say 5, we are expecting 120. Now you got the factorial of this number. Now just assume that there are two functions, f of x equal to x square and g of x equal to x into f of x minus 1. Now if you look at these two, this function g of is making a call to f of. That's fine, but the x in this context is different from the x in this context because it is within this definition and this is within the other definition. So both are different. And similarly, the n inside the main is different from the n inside this function. So don't worry about this naming convention. Sometimes you will see this, but they are different because they are local variables and they are part and visible to that block only. We will see how to access this n from inside function using pointers in future lectures. But for now, let's not worry about it. And then you made a nested function call here. So we are making a call to printf, and inside the printf we are making a call to fact. So the inner function will be evaluated first, and then its result is substituted for outer function. So even this should not worry you much. Okay, so here is your next problem to solve. You have already seen how to calculate the fact of the given number. Now using this formula for the given NCR, so you can calculate the NCR value by using the formula n factorial by n minus r factorial into r factorial. And you just need to print the coefficients of NC0, NC1, NC2 and so on till NCn. And it is very important problem to understand the functions concept. So give it a try and check back for the solution. I'm going to create a new file. I'll name it function ex6.c. I'll copy this factorial program because we need it again. Now we know how to calculate the factorial of the given number. Now what we need to do is, given the value of NCR, n and r, you can use the same function to calculate the factorial of n minus r and r. So can I say something like this? I will make a call, I will define a new function, I will name it NCR, I will take n and I will take r. Now given n and r, can we calculate NCR? Yes, how can we calculate? That is n factorial by n minus r factorial into r factorial. So what I can do, I don't even need a second expression. What I can do is I make a call to fact function with value n, then slash, that is divided by, I'll put a parenthesis, I'll make a call to fact function with value n minus r, and I will again make a call to the fact function with the value r. And this is the main advantage of functions. You just define a function once and you make a repeated calls to the functions with different values and get the respective output. And you don't need to repeat this logic again and again. And that is the main point of a function. Now here what I'm doing is I'm calculating the factorial of n divided by factorial of n minus r multiplied by factorial of r. So this is total denominator. So I just used parenthesis here to combine it. Now I know that the value of NCR. So if I make a call to NCR, I will get the value of NCR. Just that I need to supply two variables here. One is for n and the other is r. So to show you that example, I will say enter n and r, printf enter r, read the value of r. Now I just print NCR is. Now I just need to make a call to the function called NCR, and I need to supply two values here. One is for n and the other is r. As I said earlier, these two n and r are local to this function. These two n and r are local to this function. Don't get confused, and they have independent existence. Now I made a call to NCR. Now NCR will calculate the value of NCR and it returns that value, and the returned value is substituted here and it prints the given NCR value. Now let's see what is the outcome of this. GCC function 6.c. Now given, I'll say 5 and r is 2. Now the NCR value for 5c2 is 10. Now this is proper. Now we need to extend this to print the values of all these coefficients. I will write another function, print COEF of INTN. And this print COEF or coefficients is not going to return anything. So when a function doesn't return anything, you can put void. Now if you compare these two, this function says that I'm going to return an integer, but when it comes to print coefficients, this function is saying that I'm not going to return anything. Now inside this function, I just need to print the coefficients from 0 to n. So can I say intr for r begin with 0 and go till less than or equal to n, r plus plus. Now what this loop does, it starts with r is 0 and then r is incremented by 1, next is 1 and 2, next 3 and so on till n. Now I'll just say printf space %d space, and I'll just make a call to NCR because we already have it. Now pass it the value of n and the value of r. Now if you look at it, this is a static one, but r will change for each iteration. So first time it is r is 0, so this becomes nc0 and prints it. Next time r becomes 1, this becomes nc1 and then it prints it. R is 2, then it becomes nc2 and it prints it till it is ncn. So once r crosses n, this loop gets terminated and we are not returning anything, so there is no return statement. We are simply saying that we are not going to return anything. Now this is fine. Make a call, take the value of n, that is enough, then make a call to the print coefficients method with the value of n. Now if you look at it, these functions are interdependent. Now we are making a call to print coefficients. Print coefficients depends on NCR, NCR depends on fact, and fact is not dependent on anything, it simply calculates the fact. So this is how you organize the functions. You split the functionality into several modules and make sure that you use the respective function whenever it is needed. Now let's see what is the outcome of this. I'll say 5. You can see that we printed 5c0, 5c1, 5c2, 5c3, 5c4 and 5c5. And now I think you can extend this to print the Pascal triangle. Take a look at, search it in the internet and see what is Pascal triangle and try to extend this functionality. Okay, now let's try to understand what are recursive functions. We came so far, so I felt that it is better to introduce them here itself. Recursive functions, for a few people it is a nightmare, don't worry. So just understand the basic core logic, and when it is needed, then you can implement it later on. Not an immediate necessity. But still, So a recursive function, what we call it as a function that is defined in terms of itself. So if you take a look at this function, the fact, this is defined recursively. So where the given value of n is defined in terms of the same function fact itself. So to understand this better, so 5 factorial can be written as 5 multiplied by 4 factorial, and this is similar to that. So given n, if it is greater than 1, it is n multiplied by the factorial of n minus 1 otherwise. So let us see how it is evaluated first. So if I make a call to fact of 5, in order to return a value from fact of 5, the expression becomes 5 multiplied by fact of 4. Now we are waiting for a value of fact of 4 in order to evaluate this expression. Then later, instead of for fact of 4, 4 multiplied by fact of 3. Now we are waiting for value of fact of 3 in order to evaluate fact of 4. Now fact of 3 is 3 multiplied by fact of 2. Fact of 2 is 2 multiplied by fact of 1. And fact of 1 is 1, because we should stop at some point, and that point is what we call as a base condition. So here, that is n equal to 1 or less than 1 is the base condition. Now we stopped it, recursive logic. Now we know that what is fact of 1, which is 1. So we substitute it here. Now we know that what is fact of 2, 2 multiplied by 1, that is 2. Now we substitute it here. Now we know what is fact of 3, 3 multiplied by 2, that is 6. Substitute it here. Now 6 multiplied by 4, which is 24. 24 placed here. Now fact of 5 is 120. Now that you know how the recursion works, give a try and see if you can solve it and check back for the solution. I'm going to define a new C language file here. I'll say function ex7.c. Let's copy this. Now here we will be defining a function called fact, and this fact is going to return an integer, so that is the factorial of the given number, and given number is taken into n. Now look at the mathematical structure of it. Based on that, you can define the same thing. So here, if n is greater than 1, then return n multiplied by fact of n minus 1. Otherwise, return 1. So you don't need an else part here. Once the control comes inside, it is going to return the factorial value, and the control goes out from this line itself. So because if it comes here, that itself means that it is an else part. So it's an automatic else part if you evaluate it properly, so you will understand this. But anyway, both are same. So if n is greater than 1, you are returning n times fact of n minus 1. Otherwise, you are returning 1. That's all. This is a simple, very simple recursive function. Now let us take the value of n, enter n, now print percentage factorial is percentage d, fact of n. Now let's see if we did it properly. GCC. Now we got the answer. It may be slightly too much for you. If you are an absolute beginner and looking to understand the recursive functions, don't worry, just park it aside and wait for a few more lectures, and then once you are thorough with the basic programming techniques, then you can look into this one. Now if you understand it, it's excellent. but not being able to understand is not a problem. Don't worry. Now let us understand what are global variables, and as the name indicates, they are global. That means they are available throughout the program post declaration. So only after the declaration they are available. So let us see what are global variables. We will see in detail later on, but in this example I'm going to demonstrate how we can declare global variables and how we can use them. I'll name the file as global.c. So when I declare some variable here, let's say intn, now this is available as part of this function, and this is called as a local variable, and its existence or the lifespan will be equal to the lifespan of this block. That means it gets created here and it gets destroyed immediately after the end of the function. Whereas in case of global variable, they are available throughout the program. So if I declare some intn here, now this is called as a global variable, and this is available throughout the program. Now what if I have global and I also have local? So that means that local will be given the first preference. Let's not worry about those things now. Let's say I have a function, let's say read printf enter n, and I'm reading the value of n here inside the read function. N is not declared within this block if you observe, but it is available because it is a global variable. Now I'll say another function called print, and I will print the value of n. Now if you observe this, the n inside the read function and also the n inside the print function both are same, and that is the global variable. Now for now I will leave it with this simple example. I will explain it later once it is needed. At the moment this should be enough. I am making a call to read, I am making a call to print. Read will read the value of n and print will print the value of n. I will also add some /n here. Now let's see the outcome. Enter n, I'll say some 10, and you can see that the value of n is 10 because both the functions are using the same variable. And you just understand that the global variable is declared outside the functions and it is available throughout the program post the declaration. Now let's understand static variables concept. It is pretty simple, but according to me it is not much useful. But for now, let me explain you with a simple example. First I'll start with the example, let's say static.c. Now I'll just say void print, and here I will simply say int a equal to 0 and a plus plus value of a is %d comma a, and in the main I'm going to make a call to this print method thrice. Now if you look at it, you are making a call to print method. What happens is the control goes from here to print function, and a gets declared. Now it is initialized with 0, a plus plus makes it 1, and you will see the value of a is 1. And once the function ends, the local variable a which got created gets destroyed and control comes back to the calling function. Now here again when we call print, The variable a which got created is a different one, and this is again initialized with 0. A++ makes it 1 and it prints 1. Now once the function ends, a gets destroyed. Similarly, the third call also does the same. A gets created again, incremented by 1 and printed. So during all these three function calls, you will see that a different copy of a is used, and you will always see the value of a is 1. Now let us see the outcome. So this is fine. So value of a is 1, 1 and 1. Now if I declare this variable as static, now what this means? Now let us see the outcome first before we can understand. Now you can see the value of a is 1, then 2, then 3. Now what this static means is that the same copy of a is used across all the function calls. So this variable is not available outside the print function. It is only part of print function, but the variable is shared across the function calls. Now where it is getting allocated and why it is shared, I will discuss this later in the future lectures, but at the moment just think that during the first call a gets created and initialize it to 0. This statement is the initialization statement, which is evaluated only when the variable gets created. Then later a++ makes it 1, the value of a is 1 and function execution is completed, but a is not destroyed. A will remain the same. Now later during the second call, the same copy of a is used, so which makes a++ as 2, and when we print the value you will get 2. So during the second call a doesn't get created again, so the previous copy of a will be used, and again during the third call the previous value of a is incremented and that makes it 3. So you can say that the static local variables are shared across the function calls, and you can note that that is the same function calls. So all the calls to the same function will share a copy of the static variable. What is the purpose of it and the other things we can see later when it is needed. For now, this is how it is. So now we came to the most important topic, pointers. Now what is a pointer? People tend to find it difficult initially, but it is easy and straightforward if you understand it properly. So don't worry. So what is a pointer? A pointer is actually a variable which is capable of holding the address of another variable. So what does this mean? So normally when I actually give you something like this, so phone, and I put some blank here. So what is the type of value that is held by this particular area? Obviously it is the phone number. Similarly, now when I declare a variable as int a, so what is a? A is an integer variable. So what is the type of value that will be kept inside a? That is an integer, right? And similarly, when I say double b, now what is the type of value that will be held in b? So the type of value that will be kept in b is of type double. This is right. Now when we declare a variable as int asterisk p, now p is actually a pointer to integer variable. So what do you mean by pointer to integer variable? So that is nothing but it is capable of holding the address of an integer variable. So a memory block which is of type integer, and its address can be kept inside p, just like the phone number can be kept inside this part, the address can be kept inside p. So that is the point, and this is what we call a pointer, but we still did not put any address there. We can keep any integer variable address inside p. Similarly, when I declare a variable of type double asterisk q, so what q contains is a pointer to double. So what does this mean? Q is capable of holding the address of any variable of type double. And you will get more and more clarity once we get inside it. Now let us understand how this works with an example. Now first of all, when I declare something like INTA, I'm going to get a memory block which is capable of storing an integer, right? This memory block will be having some address. I will say 0x1a, just for simplicity. So then when I say int star p, so I am pronouncing this as star instead of asterisk for simplicity. Now when I say int star p, p is capable of holding an address of. Now when I say int star p, I am declaring a pointer variable. So pointer variable means a variable or a memory block which is capable of holding the address. Now what is the type of variable that it can refer to? That is an integer. So the type of content that we can place in p is int star. So that is address of an integer variable. Now the RHS of this statement actually is getting the address of a. So what is address of a? 0x1a. Now that is held inside p. So I am just placing the address of a inside p. Now this is fine. Now p means, when I say refer to p, that is this one, and when I refer to star p, so it goes one level inside and it now starts referring to this variable or this memory block. Now when we say a equal to 20, so we are referring to a directly because we do have that name. So we are actually placing the 20 directly inside a, right? And then when I say star p equal to 30, p is this one and star p is this variable itself. So when I say star p equal to 30, it is actually the integer pointed by p. And this is going to change the value of this variable to 30. So normally p means this pointer variable itself, but star p means one level above. So just take it one level above and this makes it this variable. Now when we say star p equal to 30, we are placing 30 inside this variable. And when we print a, you can see that you will get 30. Now I'll show you this with an example first so that you can understand it better. Now I'm going to create a new example file. So I will say pointer ex1.c. So now as usual, return 0. So now when I say double a comma b, now what does this mean? We get two variables of type double. Now when I say double star p, so this is a pointer variable which can point to any memory block of type double. So this is called as pointer to a double variable. And here what we declared is two double variables. Now this is what we call a comment. This is called as a single line comment. So from where it starts, if you start with double slash and followed by the text, this entire text is taken as comment and it is not an instruction. It is a simple descriptive statement that we write it for ourselves. And there is also another type of comment called multi-line comment that starts with slash and followed by asterisk and that ends with asterisk and followed by slash. So this is a multi-line comment. Normally this is written in order to write multiple lines of text. So following example demonstrates the usage of pointers. Whatever it is, this is for our description purpose. Now the single line comment starts with double slash and multi-line comment starts with slash asterisk and ends with asterisk slash, and all the lines are treated as comments. Now that is fine. Now let us come back to pointers. Now double a comma b, both we declare two double variables here, and double asterisk p or double star p. So this is a pointer to a variable of type double. And then I'll say p equal to ampersand a. So p now points to a. Now when I say asterisk p, I am referring to a itself. When I say asterisk p equal to 10.2, the variable referred by p is now assigned the value 10.2. So here it indirectly assigns 10.2 to the variable a because p is pointing to a. Now I am changing the address inside p. So I am just referring to b now. Now p now points to b. And now when I say star p equal to 20.4, now it assigns 20.4 to the variable b because p pointing to the b and asterisk p means the actual variable, that is b itself. Now b becomes 20.4, and let us print the values of a and b. A is percentage %lf because the code is double, and b is percentage %lf. I'll supply the value of a and b, and now you can see what happens. Let us compile this program before I explain it further. Pointer ex1.c. Now you can see that the value of a is 10.2 and the value of b is 20.4. So what happened here? Let me explain you. So after this declaration, you got two variables a and b in memory. Now both a and b are capable of holding a value of type double because they both are of type double. Now what is p? P is a pointer to double. So p is a memory block which is capable of holding a pointer to double. Now all a, b and p, they will all get some address in memory, because if you build a simple house, that house will be having some address, right? Now similarly, when a particular memory block is allocated to you, even that memory block will be having some address. Now let us say that the address of a is 0x123 and the address of b is 0x234. I am just assuming that this is. And now what I am doing is p equal to address of a. So what is the address of a? 0x123. I am placing that inside p. Now what is 0x123? It is the address of a double variable. Now it looks like p is pointing to this block, right? And hence the name pointer. So now when I say p, I am referring to this memory block, but when I say asterisk p or star p, I am referring to the variable pointed by p. So now I am referring to a, and hence asterisk p or star p means it is nothing but this variable a. So when I say asterisk p equal to 10.2, I am assigning the value 10.2 to a itself. And now see what happens when I say p equal to ampersand b, and that is why we call it variable. We can change the value of p as well, and the value will be the address itself. Now when we say p equal to ampersand b, Now P contains the address of B. So what is address of B? Which is 0x234. Now P means 0x234, but asterisk P means the variable pointed by P. So when I say asterisk P equal to 20.4, I am trying to assign 20.4 to this memory block. Now why I am doing this and what is the advantage of it, you will come to know in the future lectures, don't worry. But anyway, so first thing is we try to access the variables using their names, and in this example we are trying to access the variables using the pointer. Now for simple example purpose, let us assume that both A and B are two different persons living in two different locations or cities. Now let us assume P is a dispatcher of the person who is responsible to dispatch something. Now we initially assigned the address of A to P. That means we have given the address of A to P and we asked it to dispatch 10.2 to his house. So he kept inside A. And then we assigned the address of B to P and we asked him to dispatch 20.4 to the given address. Now because that P is pointing to B, so the 20.4 went to this memory location. So this is your first example and you might have captured few points from it. Don't worry, you will get more and more clarity in the coming lectures. So now we have seen what is a pointer. I would like to show you another example before telling you the purpose of a pointer. I'll just create a new file. I'll name it pointer ex2.c. I'm going to declare a simple variable of type float, or I'll take it long this time. Anything is fine. Long a equal to, I'll say 10. Now long also falls under the family of integers, so it is slightly having more space than integer. Now you can think of it as double the space than integer. This is fine. Now when I say long asterisk or long star P, now P is capable of holding the address of a variable of type long, right? Now I'm initializing it directly with the address of A. So now P is pointing to A. And I'll say long double asterisk Q. During the normal declarations, we will attach this star to the variable identifier, that is P. Identifier is nothing but the name of the variable. Now long double star Q equal to, so what is double star? It is nothing but a pointer to a pointer. So a pointer to long star. That means a pointer to a pointer of type long. Now double star Q equal to ampersand P. Now first time, here we call it A is a long variable, right? Now here P is a pointer to a long variable. Now what is Q? Q is also a pointer to a pointer of type long star. Now that means pointer to a long variable. Don't worry, you will understand this. It is easy. Now I'll print percentage LD because it's a long integer. So A is, I'll just print A. Now see the difference. I'll say star P is, so I'm going to show you the value of star P, and I'll say double star Q is, I'm going to show you the value of double star Q. Now see what happens here. GCC pointer ex2.c. Now you can see all three are same. Now this is the trick and this is what you need to understand. So here, when I declare the variable as long, I'm getting a memory block which is capable of holding a long value. Right, I'm initializing that with 10, so the value of a is 10. Now I'm declaring p, which is a pointer to a long, so it is also a memory variable. It is capable of holding the address of a variable of type long. So p equal to ampersand a. What is ampersand a? So that is address of a. I'll say 0x1a. Now address of a is held in p. So 0x1a. Then long double star q. Now q is again another variable, but the address of the value inside q will be a pointer to L, pointer to long. So that is equal to ampersand p. Now p will also be having some address, right? So let us say 0x2a, and this address is kept inside q. So 0x2a. Now what q is pointing to? Q is pointing to p. What p is pointing to? P is pointing to a. So now applying 1 star over q will take you to this level, and applying 1 star over this address take you to this level, that is a. Now see, when you say p, you are referring to this block, and you can also refer to this block as star q. Star q or p both refer to this memory variable. Now when it comes to a, this can be referred as star p or a. A means this variable, and star p is also this variable because p contains the address of this variable, and 1 star will take you one level up, that means this one. And this can also be referred as double star q. Actually, to help you easily understand this, normally this star is used for multiplication, and the same star is also used for declaring the pointer variable. So don't worry and don't get confused. If you carefully observe this particular line, how many stars you need to cross to go to the long? 1 star, right? When you apply 1 star to p, you go to the long variable long. That's it. Now when you carefully observe this line, how many stars you need to cross to go to the long? You need 2 stars. So when you apply 2 stars to q, you go to the actual variable long. So this is just like this. Now given that this is the structure and these are the values, now q means this variable, star q means p, both p or star q refer to this memory block, and a or star p or double star q refer to this memory block. And this is the star notation. You just need to understand that from q to long, you need to cross 2 stars. That's the point. And from p to long, you need to cross 1 star. So when I say 1 star, 1 level of indirection. And this is how it is. And until or unless you understand the purpose of it, you may not be clear about these topics, but don't worry, you will get into that. So in this example, I'm going to show you the first usage of pointers. Now for that, let me start with an example first. I'll create an example, I'll call it pointer ex3.c. So now I'm going to show you a simple example and tell me what is the outcome of this program. I'll say int a equal to 5 and I'll write a function called change which takes the value of b and b equal to b plus 5. So this change function is not going to return anything, so I kept void, and it is accepting an integer and it is adding 5 to that integer. This is fine. I am making a call to change with an integer, so that is a, and then print the value of a. A is %d a. Now what is the value of a that is printed? You may say it is 10, but let's see how it works. So a is still 5. So what happened here? So here, anyway, you know there are multiple functions, but control begins with main, and int a declares a simple integer variable in memory, and we initialized it with 5. This is fine. Now we are making a call to the change function with the value a. Now control goes from here to here, that is the change call. Now int b is initialized with the value of a. So this statement looks like int b equal to a. What does this mean? B is a different copy, it is a separate integer. Now b will be initialized with the value of a, so that is b will be 5. Now when I say b equal to b plus 5, b is incremented by 5 and it becomes 10. And at the end of the function, b, because it is a local variable to this function, end of the function it gets destroyed as well, and control comes back to the calling function. Now the local variable is created when you call that function and it gets destroyed when the function is completed. Now when you come back and when you print the value of a, you still see that it is 5. So now what if I want to modify a from within this function? How can I do that? I cannot do it through the name. So without even writing a, if I say a equal to a plus 5, this won't work because a is not declared within this block and it is not accessible. Now see what happens here. Now you see that undeclared identifier a, because a is not declared. This function doesn't know what is a. Now if I say int a, now this is proper, but still the a inside the main is different from the a inside the change function. So although the names are same, they have a separate copy, separate existence. Now the value 5 is copied to this variable and a is incremented by 5, so the local variable a is incremented by 5, and once the function is completed, the local variables gets destroyed, and when you come back, this is not modified at all, so you will still see that the value of a is 5. You can still see that we did not modify the a which is part of main. Now how can we modify? This can be done using the pointers, that is, through the pointer I can first take the address of A, and by using that address I can then modify the value inside A. Now how to declare the pointer? I'll say star p, int star p. So what it means, that change function is expecting an address of an integer variable. Then you cannot supply the simple integer, you need to supply the address here. How to supply the address? Using the ampersand operator. Now we have given the address of A to the change function. Now this address is now copied to P, and using P we can come and modify the value of A. So how can we do that? P equal to P plus 5 is not the right statement because P refers to the pointer. Now we need to do the indirection here. So asterisk P equal to asterisk P plus 5. Now using this we modified A. I will explain you how. And then when you print the value of A, you will see 10. Now let's see the outcome. You can see the value of A is 10. And how this worked? So we start with main. We declared an integer variable here, A. Now then we initialized A with 5. So we got 5. Now change of A. Now we are making a call to the function change with ampersand A, that is address of A. And for simplicity I will just say 10x1A is the address of this block. Now make a call to the change function with the address of A as argument. So the receiving side it is P. So P is a pointer which is capable of holding an address of an integer. Correct. We are passing the address of an integer. So the address of integer A is 0x1A, which is received by P. So the value inside this P is 0x1A. Now P means this variable, but asterisk P one level inside. So P is pointing to this variable, and when you apply asterisk you are coming to this level. So asterisk P or star P, now with star P you are referring to this block. Now star P equal to star P plus 5, star P here is the value of this block, and 5 plus 5, that is 10, which is then assigned to again the same variable. This is nothing but A equal to A plus 5 kind of thing. But why I need a pointer here? Because A is part of the main function and it is not available here. So why do you need a pointer here? And why do you need a pointer? I will explain you the reason. Now say for example you are residing in a different country or a state, and your friend is residing in a different state. Now you want to send some item to your friend. Now if you are inside the same state or in the same locality, you can directly go and give it to him, just like A equal to 5, A equal to 10, like that. But if you are residing in a different locality, then how can you ensure that this item is delivered to your friend? Obviously, you will actually dispatch it using the address of your friend. And similarly, now here A is part of the main function. So accessing A directly means you should be part of the main itself. So we can say A equal to 5 somewhere else, you can say A equal to 10 somewhere else, but it should be within the main. Now, if you are looking to access that variable from outside or using a different function, you cannot use that A directly. So you can only do that through the pointer. So using the address of A, you can access that variable and modify or see the value of it, and you can do whatever it is. So in this context, we need a pointer to make sure that we modify a local variable from outside this function. And this is first use case of a pointer. We will also see the other use cases in the coming examples, don't worry. And if you are not clear, you can still go through this lecture one more time, and still if you are not clear, you can always come back to me, ask me using the Q&A section. Okay, so here is the problem that you need to solve. You need to swap two variables using the function. Now you need to write a function called swap, and you should write the logic in a way that it swaps the values of the variables. Now hint is something like this. You have two variables A and B, and in order to swap the values, you first store the first value inside a temporary variable, so that the next statement will replace the current value of A, and the value of B will be filled with the temporary variable value. Now this is using this simple logic, and using pointers you need to write a function to swap two given variables. See if you can solve this problem and come back for the solution. Here I'm going to create a new file. I'll name it swap.c. So now here let us assume that there are two values, A equal to say 10 and B equal to 20. Now we need to write a function swap, which will actually swap the values of A and B. And here I cannot simply pass the value of A and B. If I do that, and if I declare int x and int y, now x will take the value of A and y will take the value of B. And even if you swap x and y, that will not impact A and B in any way. I will show you first. So I'll say int temp equal to x. So we saved the value of x so that we can overwrite x. Now x equal to y. Now we copied the value of y to x. Now both x and y are same after this statement. Now y equal to temp. Now we placed the previous value of x inside y. Now we swapped x and y. Now see if that is the outcome here. Printf A is %d and B is %d. We are printing the values of A and B. So see what is the outcome. You see that A is 10 and B is 20. They remained as it is, and it did not swap. So why it did not swap, we can look at it later. So now let me give you a normal solution. Now from here, if I want to access A, I can only do that using the pointer. I cannot do that directly using A itself. So I will change these two x and y to pointers. Now x is a pointer to integer and y is also a pointer to integer. So what does this mean? Swap is expecting the address of two integer variables. Now in order to access the actual integer variable pointed by x, we need to cross one star. That means once you apply a star to x while accessing, we are now referring to the variable, actual variable that is pointed by x. And here you just need to modify all the references to star x and star y. Now what did we do? Now x means this pointer, star x means the actual integer, that is A, and y means this pointer, and star y means the actual integer, that is B. But while passing the value, you should not pass the actual integers, you need to pass the address. So what is the expected value here? A pointer to integer. Now we need to supply the address, that is ampersand a. If we say ampersand a, we are passing the address of a to x. And if we say ampersand b, now we are passing the address of b to y. So I will show you how this works, but before that, let's run and see what is the outcome. You can see the value of a is now 20 and b is 10. Initially, before the call, the value of a and b is 10 and 20. Now it got replaced. Let us see how this works. So I will show you why the first one didn't work. So when we say int a comma b, we got two integer variables a and b, and a is initialized with 10 and b is initialized with 20. Fine. Now we are making a call to swap of a comma b, and control will come here. A will be assigned to x and b will be assigned to y. So what does this mean? Int x equal to a and int y equal to b. Something of this sort you can just assume. The value of a is copied to x and the value of b is copied to y. So x and y will have their own existence, and the value of a is copied to x, that means 10, and the value of b is copied to y, that means 20. Now what did we do inside? We took an integer variable, that is temp, then temp equal to x. So the value of x, we placed it in temp. Then x equal to y, we replaced the value of x with 20. Now we lost the value of x, so that is the reason we kept that inside temp. Now y equal to temp, so this temp is then copied to y. And we reached the end of the function. So all the local variables which are declared as part of this function will get destroyed. So that means temp will not exist anymore, x will not exist, and y will not exist. And at the end of the function, the control returns back to from where it was called. So we got back to the main, and now we are, if we look at the values of a and b, we did not touch a and b because we did not modify them. So it is their local copy. Now just like, say for example, you have a simple certificate here and we have given a Xerox copy or a duplicate copy of that certificate to some other person. Now if this person comes and modifies something here, is that going to impact the original one? No. So this is a copy that we have given, and this is sometimes referred to as call by value. Now see why the second one worked. Go through this one more time if you are still not clear, and before that I would like to explain you how the second one worked. Here is the case. Now let's start with int a and b with 10 and 20. So we got two memory locations a and b. We initialized these two locations with 10 and 20. Now the memory locations will have some address. I will say 0x1a and 0x2a, just for assumption. Now I am making a call to the swap function. Here I am not passing the value of a, here I am actually passing the address of a and address of b. And when you are saying the address, the receiving side, it should be a pointer. So this is a pointer to an integer and y is also a pointer to an integer. So both x and y will have their own existence, but the value inside x will be a pointer to integer, and value inside y is also a pointer to integer. Just remember this. Now the address of A is given to X and address of B is given to Y. So the address of A, that is 0x1A, is saved in X and 0x2A is saved in Y. So Y is referring to B, X is referring to A. Now we took a variable temp, which is an integer, plain integer. Now temp equal to star x. X means this variable, star x means this variable. So star x actually refers to the variable A. So temp equal to star x. So the value of A is copied to temp. Now star x equal to star y. Star x equal to star y. So we are copying 20 to A. Then star y equal to temp. What is star y? Which is nothing but this variable. That is this memory location. Star y equal to temp. So the value of temp is 10. So which is then copied to this one. And when you come out of the function, all the local variables which are declared as part of the function will get destroyed. And when we come out, you will see the value of A and B, and the value of A and B are 10 and 20. So this is sometimes referred to as call by reference, and this is only possible through pointers. So pointer allows you to access a memory location using the address. Before we can get started with dynamic memory allocation, we need to understand few more concepts here. A program, when it is submitted for execution, it is called as a process, and the process within the memory could be divided into 3 different segments. And don't worry about what is the segment, you just think that 3 different parts or sections of the memory, and one of the section is the code segment where the actual instructions are placed, and stack and data segments. This data segment is the space where we use it for all the global data, static data and dynamic memory allocations, whereas stack is used for local variables and also for storing the return addresses. For those who don't know what is a stack, stack is actually a linear data structure which follows the last in first out approach. So if I take a simple class and I put, there are 3 lemons, let's assume there are 3 lemons here, and if I put first lemon here, second lemon and third lemon, so which lemon is the one which comes out first? Is the last one. And this data structure is exceptionally useful for function calls. Let us say that there is a function call like this, f of calls g of and g of calls h of. Now once g of is completed, g of should return to, the control should return to f of. And how this is achieved? Just consider that there is a stack. Once we made a call from f of to g of, the information about where to return is saved inside the stack. Now next time when g of makes a call to h of, the return address to g of is saved inside the stack. And once the h of is completed, the last function from the stack is returned. So we return back to g of using the return address available in the stack. Now once g of is completed, the last function from the stack is popped out and we return to f of using the address available in the stack. So the stack is actually used to store the return addresses so that we can get back to the previous step once the above step is completed. Now just assume that when we are climbing the stairs, you return to the last step which you put first. So similarly, we use the stack data structure in order to store the previous function information, and we will extract that information to get back to the calling function. Now if you look at this example, the global variable will receive the space inside the data segment. Now we begin with the function main, and all the local variables within the main, they get the memory from within the stack. So A and B are allocated in the stack. Then there is a call to the function f of, so control goes from main to f of. Even before going to this function or branching to this function, the return address of main, so where to return, will be saved in the stack. Now next, y receives the space in the stack. And then there is a call to g of. So in order to branch to g of, the return address to f of is again saved in the stack. And then here x will receive the space in the stack. So once g of is completed, all the local variables allocated for g of gets popped, and then using the return address to f of, the control return backs to the f of function and continues from where it actually left. And once f of is completed, the memory allocated for f of is popped, and using the return address, we take the return address from the stack, and using it, we return back to the main function. And once the main is completed, the entire stack will be emptied and application will be terminated. So the stack is used to place all the local variables, and data is the place where we keep all the global variables, static variables, and dynamic allocations. And that is the reason why their existence will remain till the end of the program execution. Now we will see what happens here. Now at this point we actually declared a pointer because it is inside the block. So this is a local variable and it gets its space in the stack. Here p is a pointer to double. Just remember that p is not a double, p is a pointer to double which is capable of holding the address of a variable of type double. Now when somebody says p equal to 10.2, this is wrong because p is a pointer and it is not the variable. Now p requires the address of a memory block so that we can place some value inside it. So there are two ways of supplying the address to p. You can actually give the address of an existing variable in memory and then use it using the asterisk or the star p. Now if you don't have an existing variable, so we can also allocate the memory dynamically using the functions malloc. Malloc stands for memory allocate. You just need to specify the number of bytes that you are looking to allocate. And here I am looking to allocate the size of double. Size of operator returns the actual size of given data type in memory. Now once this statement executes, now you will see that the memory is allocated in the global area and its address is returned. Let's suppose that this address is 0x1a. Now this address is kept inside p. So now from here on, you can use the pointer or the address and you can refer to this memory location using star p. And once you are done with it, you need to release the memory allocated because this is allocated in the data area or the global area and it will be retained in memory as long as the program is in execution. And this is very important for you to release this memory block once you are done with it, or if it is the end of the program or end of the complete main, so you don't need to release, but because when the process is closed or exited, the entire space allocated for the process will be released. But during the execution of the program, at some point if you feel that you don't need this memory block anymore, you can call the free function to release the memory allocated for this address. Now the address is 0x1a and this free function will release the memory allocated for this address 0x1a. After that, just make sure that your pointer is invalid and you don't refer to that location anymore. malloc is the function to allocate the memory block, whereas free is the function to release the allocated memory block. And why we need to release? This is because the memory is not automatically released and it is allocated in the data area or the global address space. whereas stack will actually hold all the local variables. So once the execution of the block is done, the variables allocated within that block gets released automatically. So that means once this block execution is completed, you will see that P doesn't exist anymore. And that is the reason why it is called as a local variable. It is created during the entry point of this block, and it is released once you are coming out of this block. In this example, we will see how the dynamic allocation works. This is a simple pre-written example so that I can explain you easily. Now for this unit, you are using the functions malloc and free. These two functions are available as part of stdlib.h, that is standard library.h. Now once you include this header file, you can start using malloc and free. So when we declare the variable p, so double asterisk p or double star p, p is a pointer to variable of type double. So p is capable of holding the address of a double variable. That means when you look at it in memory, you need to assume that you got a memory variable p which is capable of holding the address, but still you did not put any address inside it. In the next step, now this malloc function allocates a memory of size double. So assume that the size is 8 bytes, then malloc allocates a memory of size 8 bytes and returns its address. And here let us assume that the address is 0x1a. Now that address is kept inside p so that we can start using the variable using the address pointed by p. Now p is set to point to this memory block. Now this is actually a double because this is actually a double variable, but here the content is double star, just remember that. Now using p we can access this variable using the indirection operator star, and here I am simply reading the value of this variable. Now scanf %lf, I am expecting a double. Now why didn't I set %p? Why I said simply p? This is because p itself gives me the address. I am not trying to read into p, I am trying to read into the variable here, the allocated variable. So when I say p, p means 0x1a, which is nothing but the address of this variable. Now earlier when we are using ABC, we are using ampersand just to extract the address of that variable. But because p itself gives me the address, so I can start using this variable simply by referring to p. Now how about extracting the value or placing some value inside this variable? For that we need to use star p. So when we say star p, we are trying to access the value of that variable. Now during this scanf, let's assume that we entered 10 and that will go into the address specified here, and the address is 0x1a, so 10 is stored inside this memory block. Now later on when we say star p, we are trying to access this variable value, so that is 10. Now once you are done with the operations, we can release the memory using the free function call. When we say free, it releases the memory associated with this address. And from here on, the address inside p is obsolete, so we should not access it anymore. Now we will see the real usage of it in the coming examples, don't worry. This is at a high level how the dynamic memory allocation works. Now let's understand what are arrays and what are the uses of it. Now here an array is a collection of homogeneous elements of same type. Now let me tell you this with an example. Let's say I am declaring a variable like int a of 5. Now here we will be getting 5 integers, and all the integers will be referred using a single name or single identifier, that is a. And how to identify individual elements? So individual elements can be identified using their index. Now here index starts with 0, so that means when we say a of 0, we are referring to the first element. Now when we say a of 1, we are referring to the second element, and like similarly a of 4, we are referring to the fourth element. So what is the advantage of it? We will come back to this, but and this is how array is organized, and this is how we can access the elements of the array. Let us see this with an example first. I'm going to create a new file. I'll say array x1.c. Now here I'm going to declare an array int a of say 5, and then we will read the values and we will print the values. That's all. We will not do much. Now let us read the values of the array. Let's say enter 0th element, percentage d, and here the element is the first element, that is a of 0. So ampersand a of 0. So now with this statement we will read a value and we will place this value in the a of 0. And similarly, when we want to read the second element, I will say a of 1. And when we want to read the third element, we will say a of 2. I'll just make this to 3. So in order to reduce the number of statements. Now we read the 3 elements and let us print the values of 3 elements. Now if you carefully observe this, we created 3 elements, 3 integer array. So we got 3 integers there, and individual elements are accessed through their index, that is a of 0, a of 1 and a of 2. Similarly, let us use the print statement to print the values. So value of a of 0 I'll print the value. Now a of 1 is a of 2, and here I will put a of 1, here I will put a of 2. Now if you observe, we read the 3 values and we printed those values, and here the value is a of 0, then second case it is a of 1, third case it is a of 2. So what is the use of arrays? We will come back, but let us execute this example and see what is the outcome. I'll rename this to .c. Now enter 0th element, let's say 10, 20 and 30. Now if you look at it, the 10, 20 and 30 are placed in 0, 1 and 2 respectively, and we read the values and we printed the values. Now what is the main benefit of an array? So we can actually write the logic on a of I instead of writing the logic on individual elements, and we can apply the same logic by changing the value of I from 0 to the required index. Let's say for I equal to 0, and I will change it till 2. Now you can see that the same logic is applied on all the elements. Now let us see how to convert this example and make it working. Instead of 3 printf and scanf statements, I will just declare a variable called I, and for I equal to 0, I is less than 3, I plus plus, and I'll just print. This is just for our sake. This is not mandatory for you to just say percentage d, something like this, and I'll print the value of I, and scanf percentage d ampersand a of I instead of a of 0. Now what happens when I becomes 0? This becomes scanf percentage d ampersand a of 0. Now when I becomes 1, this is ampersand a of 1. When I becomes 2, this is ampersand a of 2. So we simply converted the read logic and we applied the read statement on all the elements of the array by simply changing the value of I, and we can write the logic for the ith term and you just repeat that logic for all the elements, and that is the main advantage of considering arrays. Now similarly, for I equal to 0, the same statement here, and I will put simply percentage d just for output convenience. I comma a of I. Now see what's happening. So when we this is just to print for some formatted output, something like this, so that you can understand it easily. Now we first need to know the value of I in order to evaluate the a of I. So the here I varies from 0 to 2. So because it is less than 3. When I becomes 0, this is a of 0, I becomes 1, this is a of 1, I becomes 2, this is a of 2. Now if you see that the same statement is applied for all the elements of the array by simply changing the index. And this is the main advantage of it. We write the logic on a of I and we vary I from 0 to the required number. This is not a completely new one. Mathematically, we have already written these kind of statements, just like summation I equal to 1 to n x power I by I factorial. So the expressions of this sort are written for the ith term and I varies from required starting value to ending value. And similarly, this is how we have written in arrays as well. So we write the logic on a of I and we apply the same logic for all the elements of the array. And that is the advantage of using a single identifier, and all the elements are addressed using their index positions. So this is the very basic example of an array. Now let's see the outcome of this program. So that remains the same, but instead of writing individual statements, we have written them once and we have written the logic for ith term and we simply applied the same logic on all the elements by simply changing the index. So in this example, we have seen the very fundamental usage of arrays, and we will see the different usages in the following examples. So don't worry even if you didn't get it completely. So in this example, we will find the biggest element of the array, and let us see what is the procedure to do that. Now assume that we have an array of 5 elements. Now we need to identify the biggest element among the array. Now here is the logic. Normally we will consider the first element as the biggest element. That's where we start. And we will start from the second element and we will go till the end of the array. And while moving forward, we will see if there is any other element which is greater than the current one. Then we will consider that as the big. Now let us see what happens. We'll begin with I equal to 1 and we will check ARR of I is greater than big. Now if ARR of I is greater than big, then we will replace the big with ARR of I, and this is our logic. Now let us see. Now what is ARR of 1? That is 20.4. Is 20.4 greater than 10.2? Yes, then big will be replaced with 20.4. Now I becomes 2. Now what is ARR of 2? That is 9. 9 is greater than big. 20.4? No. So I becomes 3. So what is ARR of I? That is 8. 8 is greater than big? No. So I becomes 4. What is ARR of I? 30. 30 is greater than 20.4? Correct. So 30 is considered as big. And that is the end of the array. And finally the variable big will have the biggest element. Now pause this video and check if you can write this example on your own and find out the solution now. I'm going to create array example. Let's say array ex2.c. Now first I'm going to declare a double array. Let's say double ARR of 5. And I will also take two other variables int I and big. Enter 5 values. We will start with 0. We will go till 5, that is 4, and scanf, because it is double, percentage %lf and ampersand ARR of I. Now with this loop we read the values of the array So first time I 0, so we read ARR of 0. Next time I becomes 1 and this is ARR of 1. I becomes 2 and ARR of 2 and so on. Now once we read the values, now we need to find out the biggest. I'll say big equal to ARR of 0. So first element I will consider that as big. So the first element is 10.2. Now 10.2 is considered as big. And we will iterate from 1 to the 4 and see if there is any other element which is greater than 10.2. So for I equal to 1 and I will go till 5, I plus plus. Now if there is any array element, that is IRR of I, which is greater than big, that means we found something else which is greater than big. So we will consider that as the biggest element. That's all. And finally, when we come out of the loop, biggest element is big. So what we did here is we initially considered AR of 0 as big, that is, let's say 10.2 as big, and then we started from 1 and we will go till less than 5, that means 4, and we will see if there is any element which is greater than big. Now when ARR of 1 is 20.4, which is greater than big, so big is now replaced with 20.4. And similarly, next time when I becomes 4, this is then replaced with 30, and finally at the end of the loop you will find that biggest is 30. Now let's compile the program. I'm sorry, so big should be a double, it is not an integer, because individual element is a double. Now let's compile the program again. I'll enter 5 values. One is 10.2, 20.4, 9, and 30. You can see that the biggest element is 30, and the program initially read the values into the array, and later it found out the biggest among the values of the array. And finally we have printed the biggest value. Now let us understand what are double dimensional arrays. Earlier we have seen what are single dimensional arrays. So when we declare int of 5, we got an array of 5 integers, something like this. Now when it comes to double dimensional arrays, we will mention two dimensions here. One is the row size and the other is the column size. Now this is a kind of a matrix when it comes to mathematical model. Now here the row index begins with 0 and also the column index begins with 0. So individual elements could be accessed using their index. So for example, here I am going to access this element as a of 0 of 3. 0 stands for the row index and 3 stands for the column index. Because it starts with 0, so 3 represents the fourth column. And similarly, the row index also begins with 0. So if you are looking to access this element, you will normally use a of 2 of 0. So this is pretty straightforward. Let us see how to use it with an example, and I will start with a very basic example here. I will say 2D array ex1.c. Now here I am going to replicate this visual diagram. So I am going to declare an array of size 3 and 4. So that is a 3 by 4 matrix. Now here, in order to read all the values, we need two loops. One is for row index and the other is for changing the column index. For that, let's declare two variables here, I and j. So I'll start with 0 and this assume that this is the row index. So I can go till 2, that is less than 3 means 2, and I plus plus. So this is the row index. So here I am using I for changing the row index. So that is 0, 1, 2. And we will also again read j equal to 0 and j less than 4. That means j less than 4 or j less than or equal to 3, whatever is convenient for you. J plus plus. Now let us read the value of ampersand a of I of j. So in order to just make it more readable, I'll just print row and I'll print percentage d. So this is just for our convenience. Now once we are done, now we read the values, read the values of the array, and we will print the values here, print the values. So def values are, I'll print a slash n. Now same, we will again start with 0, I till, we will go till less than 3, or for your convenience you can say less than or equal to 2, and for each row j will move from 0 to 3, and we will simply print the value of a of I of j. Now I'll just give a space just to ensure that I get some space there. Now let us compile and see what is the outcome of this program. Now enter the value for row 0, column 0, I'll give 10, 20. Now you see that the values are printed like this. You may expect that this to be printed like a matrix. That is only for your convenience. You want to display that as a matrix, you can still display that as a matrix. Let's see how to do that. For each row, I will just print a new line. That's all. Whenever the row changes, we will print a new line. You can put slash n here or you can put slash n at the end. That is up to you. After printing the row, I'm going to print a new line so that the next row will go from the next line. Because we didn't use slash n, all the elements will be printed in the same row. Now let us see the outcome. Now you see, you got the output in the matrix form. So this is only for the output sake, so nothing to do with how they are organized in memory. And this is a simple example where we declared a 3x4 matrix and we used two loops to read or to iterate through all the values of the array. Here I begins with 0. Let's assume I starts here, and then for this row j will go from 0 to 3. So I 0 0 will be read, then 0 1 will be read, then 0 2 will be read, and so on. Now once the complete row is read, then I moves from 0 to 1. So again I stays here and j moves from 0 to 3. And that's how it moves. So this is the intent of this loop. For each row, we will navigate through all the columns. And then we will refer to the individual elements using aij. Now this is fine. Now I want to add one more topic to this. Now instead of reading a specific matrix, I can even request for matrix. Let's say I will declare an array of 10 by 10. Now I will read the value of m comma n. So let's say printf enter dimensions. Let's say m and n. Percentage d, ampersand m, and ampersand n. So now that they entered m and n, so we can actually iterate through till less than m and less than n. So to make it an m by n matrix, and also we can print the values like this till we go till less than m and less than n. That's all. So we made this an m by n matrix where we actually declared the sufficient or adequate size, and later on we read the values of m and n, and we read an m by n matrix and we printed the values of the m by n matrix. That's all. You see that we have read a 2 by 2 matrix. Now here we mentioned both the size of a row and the column. And this is how we can read the m by n matrix. This is pretty simple, don't worry. So we will, once we do the other examples, we will be able to know it easily. So here is the next example that we will be solving. So we need to perform the matrix addition. For performing the matrix addition, we need to have both the matrices should be of same size. So given that if it is an m by n matrix, then the second matrix should also be an m by n matrix, and the resultant matrix will also be an m by n matrix. Now let us suppose we have two matrices here, A and B. So how to calculate the added result? So it is pretty simple and straightforward. The corresponding 0 0 of the resultant matrix will be A00 plus B00, and similarly the corresponding 01 will be A01 plus B01. So this can be simply written as the resultant matrix Cij is equal to the Aij plus Bij, which is equal to the addition of the two corresponding cells. Pause this video and see if you can solve this problem and check out for the solution now. I'm going to copy this example. Let's say new file, matrix add.c. Now in the previous example, we have already seen how to read an m by n matrix. So let us now add some few other things to this one. Let's suppose that we have three matrices here of same dimensions. Now in this case, we are reading the first matrix, enter the values for first matrix, and we are reading an m by n matrix. Now similarly, I will also read the second matrix, enter the values for second matrix, and here instead of A, I will say B. Now after these two for loops, we read both the matrices. Now we need to find the added result. So how to calculate the added result? Very simple. Repeat the both the loops, and then C of I of j is equal to A I j plus Bij. That's all. So we calculated the resultant matrix Cij by adding the corresponding cells of Aij and Bij. Now let us see added result is, and we will print the values of Cij. Now for each row we are giving a break line just for printing the formatted output. So nothing beyond that. That's all. We are done with the example. Now in this case we read the first matrix, and here we read the second matrix, and then we calculated the addition result of the matrices and we placed the result in C, and finally we printed the result. Now I'll just add /n here to take it to the next line. Now let's see the outcome of this example. Enter the dimensions, let's say 2 by 2. Values of the first matrix, let's say 10, 20, 30, 40. And for the second matrix, I'll just give 1, 1, 1, 1. Now you can see that this is the added matrix, which is the result of A plus B. Now let us understand what a character data type is all about. when you declare a variable of type char, you get 1 byte of memory location. So when we say ch equal to single quote a, so this is called as a character. When you put double quote, that is considered as a string, and single quote is considered as a character. Normally what happens is when you save ch equal to a, it stores an ASCII code of this a inside the variable ch. But that is not actual a. This code uniquely identifies that this character is a. Why is this so? Normally, this is only for your understanding purpose. I'm explaining you this scenario in the text mode operations normally. So when you take a character a, so a is having a bitmap in memory, because computer memory normally stores either 0 or 1. So whatever you write, it should be translated into zeros and ones. So that I feel you will agree with me as well. Now character a is having a bitmap, something of this sort. So where 1 represents a dot and 0 represents the background color. Now when you are looking to print this character over the monitor, so a single character location is also split into the number of rows and matrix based on this bitmap. And wherever there is 1, there is a dot, and wherever there is 0, so it is filled with background color, so that you see visually a character a displayed over the monitor. Now when you are looking to store a character, you need to store this actual bitmap. So this is not possible, or it is also redundant to store the bitmap for each and every character. So what happens is each character is then given a standard code that is called as an ASCII code. So whenever you are looking to store a character, its corresponding ASCII code is saved instead of the actual bitmap. Now when you are looking to print this character, so we will say %c. %c format specifier indicates that we are looking to print a character. So what happens is while it is getting printed, the corresponding character bitmap is sent instead of the ASCII code. So this is all about the internal translations that happen. You just need to figure out that whenever we save a simple character in the variable, the corresponding ASCII code is saved and not the actual character. So you can see this value when you use %d, and when you supply ch, it will actually print the corresponding ASCII code. And let us see this with an example and check out how we can operate with the character data type. I'm going to create a new file. I will name it characterex1.c. So now I'll include stdio.h int main return 0. Now we can say character ch. This is a variable which is capable of holding a character. Now let us say printf enter a single character. And we can actually read the character using getChar. So getChar enables us to read a single character and returns the corresponding character which we can place in ch. Now here what I am doing is I am going to print ASCII code of entered character is %d, ch. Now this is what is printed. You will see the corresponding ASCII code associated with the ch, and entered character is %c. %c for character and %d for integer, which actually displays the numeric value present inside the ch. Now let us see how it works. Now enter a single character, I will say a. Now you can see that the ASCII code of entered character is 97. So the small a, the ASCII code is 97. For capital A, the ASCII code is 65. So, and the entered character is the actual value A. So, this is printed because we used %C here, and here you see that this is the number. This is printed because we used the code %D. So, to read a single character, you can use the function called getChar. Now, also there are few other functions which are helpful for you. For this, you need to include ctype.h, and you can actually check whether it is an alphabet or not. So that is, if is alpha. So this is the function which tells you whether the given entered character is an alphabet or not. So entered character is an alphabet. And similarly, if you have another function called is numeric, which tells you if the entered character numeric. Sorry, this is a digit. These are the two other handy functions which you can use. This is C, character ex1.c. I'll say A. You can see that the entered character is an alphabet. I'll say 9. You can see the entered character is a digit. Now let us understand what are strings. Strings are nothing but character arrays in C language. Now a string is normally enclosed within double quotes, whereas a character is enclosed in single quote. Now when a string is enclosed in double quotes, this is saved in the memory in the given character array like this. So where when we say A, B, C, D is stored in the character array in the given sequence, and there will be a special character which indicates that this is the end of the string, and this character is called /0, which is nothing but 0. So a string is normally terminated with /0. So till there is /0, we consider that it is a string. Now, because you already know what is a character, normally stores the ASCII code of the given character. So in reality, this is how you will see in memory within S. So small a ASCII code is 97. So next B is 98, C 99, D 100, and /0 is 0. So you will see that this is the sequence of characters which is actually stored in S. Now let us also consider a special case. Now when we declare a character S of 10 equal to ABC, now if you look at it, the actual array size is 10, but the given character string is ABC, that is of size 3 characters. So it is stored in memory like this, ABC and followed by /0. The /0 indicates that this is the end of the string. And what about the rest of the characters? Here in this case, they are all filled with some garbage value. So because there is /0, it all automatically indicates that this is the end of the string, and our string processing should end here. The rest of the characters should be ignored. Now let us see with an example how we can declare strings and how you can read the value of a string and print it. Now here I'm going to write a new file. I will name it string ex1.c. So now in order to declare a string, it is nothing but a character array in C language. So character, let's say name of 20. So I took a character array of size 20. Now I'm going to read the name. So for that we will say printf, enter your name, scanf, and the type of value that we are reading is a string. So the code is %s and followed by name. Why there is no ampersand needed here? So because ampersand is not required, what happens is this is the name of the array, and as you already know, the name of the array holds the starting address of that array. So we are already giving the address, so there is no need to place ampersand here. And printf hello and followed by percentage yes and name. So here in this example, we are simply reading a name and we are printing the name. Now let us execute this and see what is the outcome. GCC string ex1.c. Enter your name, I will say Sagar. So you can see that we printed hello and Sagar. Sagar is stored in the given character array. And now we will get back to some other interesting point here. So when we say enter your name, I will say Vidya Sagar. I got only hello Vidya, but I didn't get the Sagar because scanf by default considers the space as a separator. That means the first string that is entered is Vidya, and this is actually terminated the scanf because we read the value and the rest of the value is ignored. So that is the reason why when you are using scanf, you cannot read spaces, content with spaces. There is something special that you need to do if you want to accept a space as well, where I can specify in the square brackets, I want to read all the characters, that is a cap. Here, caret means all characters and the terminating character is /n. Either you can use /n or you can use semicolon. When you put semicolon or some other character, that means that read the string till this character is encountered. Now when I say semicolon, I have to manually type semicolon in order to terminate the read operation. Now I'll just put /n here so that when I press an enter key, it automatically ends the scanf. And this value is read into the name. Now let us see the outcome of this. I'll say Vidyasagar, so you can see that it also accepted the space. Now if I put semicolon, see what happens. I can see Vidya and I will put enter key, but still the scanf did not end. It is expecting the character to be terminated with semicolon. So I will say Sagar and I will put semicolon. Now you can see even the enter key is also accepted inside the string. That is because you typed an enter key here. So enter key is also accepted and it is placed inside the array. Now this is a small tricky one, maybe too early to explain you all those things, but still I hope that you understood this point. For now I'll just leave it as %yes to ensure that you understand it easily. So now instead of printing %yes and the name, can I read individual elements of this character? Still yes, you can do that. I'll say INTI. I'll start with I. So printf print using a loop. I'll start with I equal to 0 and till name of I is not equal to character /0, and this is the end character as you already know. So till the character is not equal to /0, you can use printf %c and name of I. So each character, you are iterating through each character, and then if it is not equal to /0, you are just printing it. So this is how you can print the character or the string using the loops. This is very useful when you are manipulating the string. So let us see the outcome. Enter your name, I will say Sagar. So there is an issue here. What happened? Because we did not increment I. So I remained at 0. So it always printed the 0th character. And because it is not equal to /0, this loop went into an indefinite loop. So we need to increment the I in order to reach the /0, right? Enter your name. So I printed Sagar using the loop. I'll just print a /n. You can see the printed Sagar using the loop. So here is the example that we need to solve. So we need to check whether the given string is a palindrome or not. Palindrome strings are the ones which can be reversed and it still remains the same string. Now when we say little or Malayalam or madam, so even if it is reversed, you can see that that will remain the same. Now how to check this one? It is very simple. So you need to check the first character with the length -1 character and second character with length -2 and so on. So if they matches, then you can say that this is palindrome, otherwise not. So give it a try and see if you can solve this problem and check out the solution now. Going to create a new file. I'll name it string ex3.c. So first we need to read a string. Let's say character s of some 20. Enter some text. %yes, comma yes. So now we read the character. So we want to check if the given string is a palindrome or not. And for that, first we need to find out the length of this string. So for this, what I will do is I'll declare a variable I length, and we'll come back with other variables what are needed. So first you need to find out the length of this string. So in order to find out the length of this string, what I can do is length equal to 0, I equal to 0. We'll start with I 0, while s of I is not equal to /0, I plus plus, and then also length plus plus. Finally, at the end of this loop, if you look at it, you will see the length inside the variable length. Or I can also do it in this way. I will say write a function length and I will pass the array to this, string to this. I will say int length of character s of, and then here I will actually do the same thing, length equal to 0. In order to not to confuse you, I will also make I equal to 0, while s of I not equal to /0, I plus plus and length plus plus. Finally, you return length. This also works, and you don't actually need this. You can actually, what you say is s of I is not equal to /0. Till that you just increment I and finally return I itself. So that also holds good. Even this works. Or you can say s of I plus plus not equal to /0. You don't even need this block. You can say semicolon because you just need at least one statement within while, and that single statement is the semicolon itself, and I is incremented later. So the current value of I is 0. So s of 0 is not equal to /0. Now what if s of 0 is /0? So you will be returning the length is 1 because I will be incremented later on. Now instead of this, what I can do is I will start with -1 and I will increment I before. Now I made it 0, then s of 0 is not equal to /0, then s, that is true, s of 0 is not equal to /0. So then it comes inside, then I becomes 1 and s of 1 is not equal to /0. Like that, it goes till /0 and it returns the actual length. This also works. Or instead of writing all these things on your own, don't try to reinvent the wheel. Just check if you already have a function present. There is a function called strlen which returns you the length of the string. So don't worry about all those things. Now we know that what is the length of the string. We just need to check whether this particular string is a palindrome or not. Now I'll say that palin equal to 1. Yes, I will feel that it is a palindrome and I will prove if it is not a palindrome, I will prove that it is not palindrome. So let us begin with I equal to 0 while I is less than length by 2. You just need to go till the half of the string because rest of the halves you will be automatically verifying whether this is palindrome or not. One point index starts from here to here and second index anyway it comes from here to here. Now let us go till length by 2 and then if s of I is not equal to s of length minus I, minus 1 minus I. So then what happens? Just check this case here. S of I is 0. Yes. S of 0 is not equal to s of length minus 1. Length is here 9. So the actual string length is 9. 9 minus 1 is 8. Length minus 1 minus I, that is length minus 1, 8 minus 0. So 0 is compared with 8. Now if it is not equal to, that means it is not palindrome. So I can say palin equal to 0. I thought it is palindrome, but now that I know it is not palindrome, I made it 0 and I can break. I don't need to proceed forward. Now just check this case. I equal to 0. I is less than length by 2. Length is 9. 9 by 2 is 4. I is less than 4. Now s of 0 is compared with s of 9 minus 1 is 8. 8 minus 0, that is 8. S of 0 is compared with s of 8. Is it equal? Yes. So I plus plus I becomes 1. Then 1 less than length by 2, that is 4. 1 less than 4 is true. Then come inside, s of 1 is compared with s of 8 minus 1. So that is 7. So s of 1 is compared with s of 7. If it is not equal to, then it is not palindrome. Yes, it is equal. So this if condition doesn't run, then I plus plus I becomes 2. 2 compared with 6. 3 compared with 5. Then I becomes 4 and 4 less than 4 is false. And since all the characters matched, the variable palin will be having 1 itself. So after the end of the loop, if palin equal to 1, that means it is given string is palindrome. Else given string is not palindrome. So that is the logic. Now this can entirely shifted into a function. What I will do this here is I will write a function called isPalin and I will take the given string and I will return 1 if it is a palindrome, otherwise 0. So what I will do, I will declare two variables I and palin, which is equal to 1. Now I will return palin. So palin contains 1, then 1 is returned. Palin contains 0, then 0 is returned. Now if you look at this function, we are doing the same thing. We are making a call to isPalin. So I will say isPalin of s. If it is equal to 1, I don't need I, and I think we need length here. So I will move this inside the length function. I don't need all these variables here. Now check out this one. I'm checking if it is palin. Is palin of s. If this function returns 1, then I'm saying it is palindrome, otherwise it is not. Now inside the function, I'm taking a variable called palin. I'm indicating that this is palindrome. Then if I found that there is some character which is not matching, then I'm saying it is not palindrome and I'm breaking the loop. Finally, at the end of the loop, whatever remains in the variable palin, I'm returning it. So it will be 1 if it is a palindrome, it will be 0 if it is not a palindrome. So you don't even need to do this. I can remove this. I can say return 0. Return 0 automatically takes you out of this function. So it is a break kind of statement, but it is beyond that break. This actually returns from function itself. Now if the control comes out, that means that is a palindrome. I can say it is 1. Now if you are confused with zeros and ones, it would be a better practice to actually declare a constant palindrome or true equal to 1, false equal to 0. Let's declare these two variables, true and false, and return false because it is not palindrome. Return true, it is palindrome. Now during the verification, don't compare with 1. You can say if is palin equal to true, then you can say it is palindrome, otherwise not. Now we replaced these ones and zeros and we made it slightly more readable. So we are returning true if it is palindrome, we are returning false if it is not, and here we are comparing with true. We don't even, in C language particularly, we don't even need to do this. I can even remove this equality condition. Now let us see if that works. Now let's say, madam, given string is palindrome. Let's say some text, given string is not palindrome. So here are the few other interesting string functions to consider. You can include the header file string.h for these functions. There is a function called strlen which you have already seen. This returns you the length of the given string. So strlen of abc will give you the length 3. And similarly you have another function called strcpy, and this copies the source string into the destination string. Please make sure that you understand that source string is in the second argument and destination is in the first argument. This is similar to what we do when we say a equal to 10. 10 is copied to a. So similarly source will be on the right side. Now strcpy of s2 comma s1 means the content of s1 is copied to content of s2. Now similarly there is another function called strcat, string concatenation. This is used in order to combine multiple strings. When we say strcat of s1 comma s2, the content of s1 is appended with the content of s2. So this is how the resultant string is going to be. Given that s1 is abc and s2 is xyz, you will find S1 value is abcxyz once you complete the function call strcat. And similarly, there is another one important function called strcmp, which is used for string comparison. So what is string comparison? So you initially, for your simple understanding, you consider that that is a dictionary order, except that you need to know that the capital A is always less than small a, because capital A ASCII code is 65 and small a ASCII code is 97. So this is what you need to understand when you are comparing two strings. So when we say strcmp of str1 comma str2, now it returns a positive value if str1 is greater than str2, and it returns a negative value when str1 is less than str2 and equal to 0 when both are equal, and internally the return value will be the difference between these ASCII codes itself. Now just to understand that C is less than D, so C ASCII code is 99 and small d ASCII code is 100, so 99 is less than 100, hence C will be less than D. But in case of capital ABC and small ABC, you will find that capital ABC is less than small ABC because the first character ASCII code is capital A, and that is 65, and small a ASCII code is 97. So all the entire string is matched till a difference character is found. And if you look at this example, small ab less than abc, for simple understanding you can consider this as dictionary order, but in reality what is going to be compared is slash 0 is compared with c, because the third character is slash 0 in the first string. Slash 0 means 0. 0 is compared with C, which is always less than. 0 will always be less than the ASCII code of C. And these are the some of the interesting string functions which you can use during your programming, so that these functions will make our life easy. Now let us understand what are structures in C language. Structures are also called as records, where you can consider them as a group of fields combined together with a name. Let's say, for example, you have a student record with all the required fields, or maybe a course record with all the fee details, name of the course and the price of the course, etc. So similarly, you can create your own structure using the keyword struct and followed by the name of the structure. The name actually gives you an advantage to declare the variables in the subsequent part of the program. Now this is a sample structure, so struct point with two fields x and y. Now when you declare a variable p of type point, you get a copy of all the fields which are part of the definition. Now that means x will have its own memory and y will have its own memory as part of p. Similarly, when you create another record q, even q will have its own copy of x and y. And this is how it works. You may also consider this to think like this memory structure. This is also fine, just for your understanding purpose. Here what this says is that q is having two fields x and y. So ideally this is how you should think about a record. Now how to access the member x and y? We need to use the operator dot. Dot is the membership operator. When we say p dot x, we are referring to the x as part of p, and when we say q dot x, we are referring to the x which is part of q. So that is how it is. Now let us see a simple example on this so that you can understand these things better. Now let us write a simple example to demonstrate how we work with structures. I'm going to create a new file. I'll name it struct.ex1.c. So first, to declare a structure, we need to use the keyword struct and followed by the name of the structure, whatever the name you want. And inside the structure block, we will specify the field data type declaration. So that means what are the fields which are part of this structure? I will say x and y. Now you need to end it with semicolon. Now later on, if you want to declare a variable of type point, then we can also make the declarations here to make a variable of type point. Now let's not do it now here. Now we will create two variables, struct point p comma q. Now we got 2 points, that is p will have its own copy of x and y and q will have its own copy of x and y. Now let us read the 2 points. So how to do that? Printf enter x. Now we will be reading the value of x inside p. So scanf %d ampersand p dot x. Now here it is, x is not a direct member or not a direct variable here. It is part of p. So p will have its own copy of x. Now we are reading into the x which is part of p. Now similarly, printf enter y scanf %d ampersand p dot y. Now we have read x and y fields of the record or point record p. Now similarly we will also read the second point, enter x. Now this time we will put that into q. So q dot x and q dot y. So to be more clear, I will say enter first point and enter second point. So now that we got both the points, now I will calculate the distance between these 2 points. So the distance between the 2 points could be calculated using the formula square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now let us use this formula and calculate the distance. And in order to use the square root function, I will include math.h. And then I will create a variable called diff x and diff y. So to calculate the difference. So the difference between diff x equal to p dot x minus q dot x. Now diff y equal to p dot y minus q dot y. Now how to calculate the distance? I will say double distance. Now distance equal to square root of, so sqrt, x2 minus x1 whole square, x2 minus x1 is part of diff x, so x diff x times diff x, which is nothing but x2 minus x1 whole square plus y2 minus y1 whole square, so diff y times diff y. Now we calculated the distance. Now let us print the distance. Is %lf distance. Now let's see what is the outcome of this. Struct tx1.c. Now enter the first point, I will say 10 and 20. Second point, I will give something. So to make it easy, I will say 9 and 19. So 1 square plus 1 square, square root of 2, somewhere around 1.414. Now this is your first usage of structures. We will understand these things better in the following examples. Now let us quickly understand what are pointers to records or pointers to structures. Now we have a structure here, which is a point with fields x and y. Now when we create a structure variable, record variable of type point, p will get its own copy of the entire set of fields. So that means x and y will have its own memory blocks. Now p dot x will refer to the x field within p and p dot y refers to the y field within p. Now what this declaration means? So struct point star ptr. PTR is a pointer to a record of type point. So that means PTR will occupy some memory space in memory which is capable of holding some address, and this address might belong to a record of type point. So that is what it means. So PTR is a pointer to a structure or a pointer to a record of type point. Now this is the difference between these two. Now when we assign the pointer variable the address, we can now access the fields, and here PTR is referring to P. So through P, if we want to access the fields, we should use dot operator. But through pointer, if you are looking to access those fields, we need to use of operator, which is minus and greater than symbol combination. So PTR of X refers to the X field of the record which is pointed by P, and PTR of Y is the Y field of the record which is pointed by PTR. This is how it is. Let us see this through an example. So I'm going to modify the previous example that we have written, and I want to convert this into a function. See, I want to write a function called read, which is capable of reading the record, and similarly I want to convert this to a function call which reads the point q. Now if you look at it, p and q are record variables which have their own copy of x and y. Now when we call the read function, we should be capable of reading the x and y inside p. And in order to do that, we need to call this function by reference, because we are looking to modify the p and q inside the read function. So we are trying to assign the values to the p and then to the q. Now in order to do this, we need the address, the reference operator. So here I'm going to write a function called read which accepts a pointer to a record of type point. Now we will actually do the read scanf calls inside the read. Now instead of q dot or p dot, I will say ptr of. So this is how it is. Here I am doing a scanf. I am reading the content and reading an integer value, and we are placing that inside the variable x of the record pointed by ptr. Now the first time ptr will point to p, so the xy will fields refer to the fields of the p. Now next second time when ptr is referring to q, so the x and y fields refer to the xy fields of q. So now we read the values into the given records, and then we calculated the distance and we printed the distance. And here I want to print the values as well. So I will say print of p and print q. Now because I am not trying to modify anything inside the print function, so I can take it by value. Let us define the print function now. Void print. I'll take a structure point, say for example some, let's say t. Now I will print the values. Printf, I'll just put %d comma %d, and I'll print the value of x and the value of y, and I'll print a /n. Now what is the difference between these two? This is a pointer, this is expecting the address, but this is expecting the record. In this case, the content of p is copied to t. So many modifications done to t will not affect the given point. Similarly, when we make a second call, the content of q is copied to t, and t dot x means it's its own copy. So this is called by value and this is called by reference. Now that's the difference between these two. So here in this case we are taking the address and we are referring to the original record. Now here in this case we are taking a copy of the original record. So this is called by value and this is called by reference. So that's the difference between these two. I'll just say point P is so this example demonstrates how to refer to the record using pointers and also how to pass the records to functions. Two ways of passing the records, one by value and one by reference. So by reference is pointing to the original record, just remember that, and by value simply takes a copy of that record. Now let us see how this works. So there is this mistake PTR. First point, let's say 10, 20. Second point, let's say 8 and 18. So this is what is the obtained end result.
So now let's quickly understand what is typedef as well. So I'll create a new file. I'll name it typedef ex1.c. Let's copy the sample blank. Okay. So what is typedef? So typedef allows you to create or declare new types from existing types. It's not about creating new types. You are giving an alias kind of thing. You are having some better name for an existing type. Say for example, typedef int and I'll say age. So when I declare a variable something like age a, now if you look at this declaration, a is an integer indirectly, but we call it as age. So, or I will say maybe to look somewhat better, I'll say currency. So, and when I declared a variable of type currency, so it is internally double, but you named it as currency. So the double can now be referred as currency in the example. So you give a better name for an existing type. That is what is the purpose of it. The rest of the things all remain the same. Yeah, equal to 10.2. It's all double. So printf a is percentage %lf and a. So all the things applicable to double also applicable for a. So that's how it is. So let's compile this program. Got it. Now there is one other advantage for typedef. So in some scenarios it also helps. So let's say I have something like struct emp with employee number and salary fields. Now when you are looking to declare a variable of type emp, so you are supposed to declare it this way. Say emp e. Now you need to prefix this with struct. That's what the rule is, right? Now you need to always prefix that with struct and then emp and e. And the prefix actually says that this type emp is of type struct. So structure. So if you want to avoid this, you can also do it in a different way. I will say struct and I can normally when you put this here emp, you need to remember that this is a variable. Okay. So when I say typedef, I'm defining a new type and that is structure. And this entire structure is named as emp. So this is not a record here. This is the type because you are using typedef. You remember that if all the fields are obtained into a single line, so you are declaring a new type from an existing type. The existing type is structure with fields envo and salary, and is now named as emp. So from here on, you don't need to prefix this with struct. You can simply say empe, and sometimes this helps us remove the struct prefix from all the record declarations. So that's the main goal. And rest of the usage is as per struct. So e.envo, e.salary, etc., etc. So e.envo equal to some 10, e.salary equal to something, and printing those values, they all are same. envo value is %d e.envo, and printf salary value is %lf e.salary. Okay, so that's it. So that is typedef for you in short. Now you understood what is typedef. Okay, great. Let's move on. Now let us understand what are command line arguments. So to demonstrate that, suppose say for example, if I say ls-ll, this -ll is a command line argument. Similarly, when you are making a call to copy or cp some source and destination, so the source and destination here could be considered as arguments. So to the command cp. So it's a copy command. So you are making supplying the value of a source file name and the destination file name. In the similar lines, now when you are building a command line tool, you might want to accept some values from the one who is invoking that command, maybe some data. So in that case, you can also accept those values, and these values are actually received by the main function. Main function receives two arguments. One is argument count and the second one is argument vector. It's an array of strings, all the values in the form of a string. Now you need to interpret based on your requirement, and then you perform the action accordingly. So argument count gives you the number of arguments passed, and argument vector gives you all the arguments. Now this simple example, cmd line 1.c, will simply print out what are the arguments passed to the program. Now I'm just saying I equal to 0 and I less than argc argument count, and I'm just printing each argument. So I'm just for understanding purpose, I'm saying argument and the argument index and the corresponding value, and the value is argv of I. It need not be argc or argv. Names is as you wish. So you can name according to your need. That's fine. Now when we compile this command and when we pass the arguments to this program, main is going to receive it. Let us see how it works. gcc cmd line 1.c. It compiled the program, and now when I say a.out and followed by 10, 20 something, now you can see that. So these are the different arguments passed to the function, and you also need to know the first argument itself is the source file, the source command. So the first command itself is given as the first argument, and then followed by the values. These values, although I have given 10, 20, it need not be. It could be anything, or it could be the name of the file, whatever it is, but they are accepted as a string. Now you need to know what that value is, and you need to act accordingly, right? So the 0th argument is the name of the file. Now let's see how to interpret it. So the first argument or the 0th argument is the source command, and followed by all the argument values. So now based on this assumption, you might need to skip the first one and then start accepting the values from the second argument. So this is a simple brief introduction about command line arguments. In the next example, we will dive slightly deeper into it and try to write some utility. So now that you know how to accept the command line arguments, so let us start with some very good example, simple example. So that copies the content of one file to another. So let us try to rebuild our own copy command. But this particular example requires you to open the file for reading purpose, and you need to open the destination file for writing purpose. And let us see how we can do it. But before getting into the command line, let me demonstrate you how to open the file for reading and then open the file for writing and how to exchange the content. Okay, so there is a function called as fopen. Fopen will let you open the file, and here you want to give the source file name. So let us say source.txt and which mode you want to open the file. So R stands for read mode, W stands for write mode, A stands for append mode. Now you want to open the source file in read mode. So fopen will let you open the file, whatever the file name that you give, and the mode in which you want to open the file. And if you look at it, it returns a pointer to the file, which is like a handle to that opened file. So you need to have some variable of type file star, file pointer. So I would say source file. So opens the file and then it returns a pointer to the source file. Now we have the pointer to source file. Now we can read the content of the file. Similarly, you need to open the destination file. Destination file fopen, I'll say destination.txt. And this I want to open it for writing purpose. So I would use the word W for writing. So now we opened two files. One is source.txt in read mode and the other destination.txt in write mode. Now we need to read the content of source.txt and we will start writing the same content to destination.txt. So in order to read a single character or single byte from the file, you should use something called as fgetc. Fgetc reads the content from the one character from the file, so that is source file, and it returns you a single character. So I would say character ch and then ch equal to fgetc from source file. This particular function reads one character and it returns, we are holding that in ch. Now the same thing, you read one character, now you need to write it to destination. So there is an opposite function fputc which takes the character and a pointer to the destination file or a pointer to a file so that it writes this character to the destination. Now these two steps you need to repeat till there is content in the source file. You read a character from the source file, you write it to the destination file, and you need to repeat these two steps till it is end of file, right? So for that, we will put that into a while loop. While you read the content till it is not equal to end of file, you write the content. Let's evaluate what is happening here. You need to look at the parentheses here. First, internal function, internal parentheses, this is evaluated. The result of fgetc, so the red character is assigned to ch. If that is not end of file, then we are simply writing it to the destination file. That's it. It's very, very simple logic. Just carefully look at it, you will understand. Now, at the end of the loop, let's close those files because you don't need them anymore. Fclose of source file and fclose of destination file. And this is your logic. Now this is good, but we have pre-assumed that there is some file named source.txt. It need not be source.txt, it could be a.txt, destination is b.txt, whatever it is. So I'll just create a new file called a.txt I'll put some content into it, save it. Now you need to go to the command line, just say gcc cmd line 3.c and execute it. Now you should see another file named b.txt because it is not present. So it's open for writing. So the file gets created automatically. And then the content of a.txt should be there in b.txt as well. So click on it. You can see there is some content. That's fine. Now we know how to open a file and how to write the content into the file. Now let's accept these two file names from command line and process the copy command. Let us remove this b.txt now. I'll just retain a.txt. Now this is my first argument. So if you look at the copy command, this is the first argument, which is the source file name. So I can say a.txt, destination b.txt. Now this is argv of 0, right? The source file, the command itself is argv first argument, and then this should be argv of 1, and this should be argv of 2, correct? So argv of 1 is my source command, source file. argv of 2 is my destination file, right? So we translated this to command line arguments, that's all. But we just ensure, let us first ensure that we are getting all the arguments as per the need. So what I will do, if argument count is not equal to 3, so we are expecting 3 arguments, right? So 1 is anyway that is passed, 2 and 3. If we didn't get 3 arguments, we will say printf usage. So this is not the way that you are supposed to use. Copy and source file and destination file. And because we did not receive the right kind of arguments, so let us exit the program with status code 1. Normally this is a convention. So you return 0 means it is successful. It need not be exit at this point anyway. You can say return 1, that's also fine. 0 is normally successful exit, and 1 is normally failed. So we say that it's failed. That's fine. Now, if we did not receive 3 arguments, we are saying that this is the right usage for this, and then we are terminating the program. Now, if we come below, so then we should be able to open the files and then perform the operations, but the declarations need to be at the top of the block. So what I'll do, I'll just move this declarations and character ch to the top, and I'll say simply source file equal to destination file equal to. So we don't need this anymore. So we moved the declarations to the top. Declarations are supposed to be present at the beginning of the block. All the local declarations should follow the beginning of the block as far as C language is concerned. So that is something that you need to remember. So then if we don't receive all arguments, then we said this is the usage. Otherwise, we started opening the file and destination the file in write mode, and we have written the content. So now another question. What if the source file doesn't exist? So it's not there. So then what will you do? So if src file equal to null. Now if it is unable to open the source file, this fopen returns null because it's a pointer, right? So if it returns null, so it is not able to open the file. In that case, we can say printf %s file doesn't exist, and let's give the name so that and then you can terminate the program anyway. So if we are not able to open the source file for reading, then we say that particular file doesn't exist, or unable to read that file. We don't have the right kind of permission to open the file for reading. And in the similar lines, if we are not able to open the destination file for writing, so that we percentage yes could not be opened for writing. Okay, so it could be a permission issue, or disk might be full. So there may be several reasons. So if we are not able to open the file for writing, then we are saying we could not open the file for writing, so we are terminating the program. Now, if we crossed all these steps, then we started reading from the source file and we started writing it to the destination file. And once done, we closed those files. So we built a simple command line utility to perform the copy operation. Congrats. Let's compile and see if we are getting the expected results. gcc cmd line 3.c, and I'll give the output file as copy. Okay, /copy, and I'll simply put enter. You can see that it has shown us the usage. Maybe /n might have done the trick. Okay, so let's put some /n. Okay, so gcc cmd line 3.c -o copy. So you can see it has shown us the usage. I think you should remember that if you are writing, if you are making an invocation of a command in an improper way, you are looking at the same things, right? Well done. So now you are there. Then let us see copy a.txt to b.txt. You can see a.txt doesn't exist because I deleted it. So it has shown us that a.txt doesn't exist, right? What I'll do, echo hello world to the file a.txt, right? Then I didn't write that. So echo hello world to a.txt. You can see a.txt got created with the content hello world. Now let's do the copy command. Copy a.txt to b.txt. Right? You got the file, right? So hello world. Well done. So that is how we can build the command line tools. And in order to build the command line tools, it's very, very essential to understand how to accept the command line arguments. You did the great job. Now you know how to write the commands and how to accept the command line arguments. You now know how to build the command line utilities. Well done. I'll see you in the next lecture. Our C language understanding is incomplete without understanding preprocessor directives. So what are preprocessor directives? When you look at the program, you can see there are some special instructions that starts with hash symbol. So here hash or pound symbol. So this is the first non-white space character. It need not be in the first column. So it could be somewhere else as well. Even that is fine. But it is the first non-white space character. So this is the instruction for preprocessor. It's not the instruction for compiler. So this is taken care by preprocessor and it performs the necessary translations. Now here hash include means it instructs the preprocessor that you need to include the complete file stdio.h within this program. So the entire file is expanded and then it is submitted for compilation. So we will get into that in the later point. So let us first understand some other very interesting preprocessor directive before we dive into understanding what is preprocessor. Okay, so let's do that with a simple example. So suppose consider I am creating an integer array of 5 elements. I'm going to read the values into the array. So first to declare the integer for I equal to 0, I is less than 5, I plus plus, enter values into the array, and scanf %d ampersand a of I. And to print the value, printf values in the array are, and then we will again use a for loop to print the values. Instead of scanf, let's put printf, and I'll give a /n. Okay, so this is not the right way of writing the code. So you can write it. Is actually this program compiles, but if you look at it, we are declaring an array of 5 values, and then within both the for loops we are using that 5. So here 5 is the limit or the maximum number of elements that you want to consider in an array, right? So in that case, it's always better to declare a constant. So for example, if I make this 8, I need to go and make these 2 occurrences as 8 as well, right? So instead of that, what I'm going to do, I'm going to define a constant, say limit, and I will give the value 5 to that. Then instead of constant, I'll put the limit. So you declared an array of the given limit. Now you are going till the limit, and here also you are going till that limit. So this makes the program more readable rather than simply using 5. Whenever your code becomes more and more readable, it's always important to have that constants. So or constant int limit equal to 5. Okay, now let's compile this. gcc preprocessor ex1.c. I can see enter the values into the array. I'll say 1, 2, 3, 4, 5, and these are the values. So there are 2 ways. Here constant int limit, if we declare it this way, so this is going to occupy the memory, and it is given the integer memory block, and then whose value is 5. But in case of hash define, this is considered as a macro. So whenever there is an occurrence to limit, the preprocessor is going to translate this program, and wherever there is limit, it simply replaces that limit with this value. So that is the preprocessor directive, and this is sometimes called as a macro as well. So all the macro references are replaced with the corresponding definition. You will see the usage of hash define more and more in the programming. Okay, now let's run this program again and see what is the outcome. Yep. Now let's understand how hash define operates in a different example.